Welcome to JobSkillShare.org Junior Network Engineer Training Program provided by JobSkillShare. Now, if you remember, this video is definitely for you after when you finish your test out training in this week. Now, if you are not a member, you can still go through this whole live session, and it's going to teach you a lot of real world concepts. And even though we are talking about a lot in the concepts, but we're teaching you or showing you some of the real equipment to give you an idea of how infrastructures are now using certain things like firewalls, storage, cloud computing. So it's important for our member to really go through the test out, which here in week 5 you have to finish 8.1 to 8.3, which is going to talk about a lot about firewall, from all the way from basic to a little advanced. And then after that you're going to do network customization, which is going to be like a hybrid type of solutions where you have storage, you have VoIP, you have virtualization, virtual networking, cloud computing. And at the end, in this whole session you're going to do some labs, but also we're going to do or teach you or show you real systems or AWS and real storage systems, how they're connected. The problem with real world teaching in this area is that a lot of trainings will not give you a very expensive data center that is worth $200,000 or $100,000 plus equipment in there. And that's how normally it is in US. When you have a data center, you have to, if you have 400 or 500 or more than that people, you will have to configure something like that, and you have to purchase it from Cisco and other very big vendors, and it's going to cost money. So trainings are done either on a kind of like a theoretical way or some type of systems that are more virtual. But here in our training, we're trying to give you some ideas now. We're going to show you in this real training how these expensive systems look like. And that's the problem with a lot of people. If you were to become an engineer, you just can't expect you to walk into a building and just know that I know switch and routing and that's it. These days, you're working on a hybrid system. These are interconnected, whether it's a cloud, virtualization, everything. If you're an engineer, they expect you to know a lot of these things at the basic level if you're not going to be that specific engineer for something. But if you were going to be working for a one-man IT shop and you were to be named as an engineer, I just don't know how you're going to get away with this stuff. So it's important for you to first go through your test out, material. Why is that? You have to learn what firewall is. Then it lets you practice on a very basic level, from starting from a Windows, going to exactly how it works on an endpoint, and then it teaches you a little more advanced. It takes you to more ACL, DMZ, proxy, and what that is. It gives you a lot of idea of what that is. And then in this live session, you're going to learn more real world solutions, or how we can show you some ASA stuff. How does it configure on a real world? So the image will clear in your mind. And then when it comes to network customization section, that's a pretty big area. Each and every single area in this is a monster on its own, but you don't need to really go into extreme deep because you're still in a Network Plus course. But we are still not going to take this lightly, because we want to teach you after this test out when you finish it. And now when you watch this live training for 3 hours, I can guarantee you walk into any data center, at least you will know what's going on. Yes, after that you need to go deep dive into these things, and that's where you become a senior network engineer or a mid-level engineer to understand some of the, like, for example, virtualization. You can even land a job just doing a virtualization job. You can even land a job right now just doing cloud computing. But nobody expects you as a junior network engineer to be a very top-notch engineer in these areas. They just want you to know the basics. Can you get into certain things? Can you start services? Can you troubleshoot some basics? And that's it. That's where they will get you as a junior level. I hope you will take my introduction seriously. You will finish the test out first, and then you will take our live session. If you're not a part of our program, you can join our program by going to the description and registering for our new batches. But if you feel like you can do this on your own, first try to understand what these things are, and then you can watch this live session and take some notes from the live session, and then maybe you do your own research after that. But good luck with this session. It is going to teach you a lot of these different areas. And now we're going to move into more specific areas in networking the other side, and hopefully at some point we're going to get into CCNA, which is going to be very deep level in networking.
Okay, so let's continue. So today I'm going to hit week 5 module, and if you have already gone through in test out lab, this is like they are talking about the firewalls, network customization, and which is if you go in detail, like firewalls, virtualization, cloud computing, and the storage. So our agenda is same. We will look into these concepts in detail, and if you have any question or doubts, you can just interrupt and ask on the spot, and then we will go through some labs as well. We have like 3 to 4 labs, and which is very interesting, and there are some new concepts as well. So without further ado, let's jump onto the quiz. Just very quickly, just go through one by one. What is firewall? Just what is your idea about firewall is?
Firewall can be a software or a hardware that protects your network from incoming traffic. Exactly.
That's great. From outside traffic coming to inside, or even from inside to outside as well. What ACL stand for?
Access control list.
Access control list. That's great. What is the DMZ?
Demilitarized zone.
Yeah, that's fine. The difference between NAS and SAN?
I can't remember that.
Oh, but no problem. But what are these things? If somebody is talking about the SAN, what you get? Means you have any idea?
From my Go ahead.
Go ahead.
From my understanding, SAN is the network of the storage. When you want to share a storage, you build a network.
Yeah, exactly. So these are basically the storage types we will discuss, in the session as well. So what protocol mostly being used in VoIP, and what VoIP is first of all, and then tell me what protocol, if you have any idea about, no problem. If you don't get, no problem.
Voice over IP, and I think it's using. No, I don't want to say anything wrong. I don't know.
Okay, no problem. Anyone?
SIP, SIP, because it's open source.
Yep, SIP and SCCP, these two protocols being used. So SIP is, yes, it's open source. That's the reason it is in the market. What is virtualization?
Virtualization, sorry for the background noise. Virtualization is basically hosting servers and hardware virtually.
Okay, Crystal, what is your take on this virtualization?
For me, I would say it's a kind of using a resource. I mean, it's a little bit, it's bigger. I cannot say in
no
less
problem.
words.
No problem.
Sorry. So we can simulate a system. We use virtualization.
Yes, exactly. Yeah, both are correct. Basically, we have multiple, instead of purchasing, multiple hardware appliances, why not we purchase one device and then do this virtualization on top of that, so we can have like 5 devices running on the same device. So this is the basic idea of virtualization. So what is the benefit of cloud computing?
It is, so when you say, okay, there's a lot of benefits to cloud computing, but I think that the security is usually run by whatever company you choose to work with, AWS, Azure, and then less physical space in a building, and then finally I think it's less overhead cost, and then the ability to I think it's called elasticity.
Yeah, elasticity, scalability, so many things under it, but okay, go ahead.
And I will add that in case of an incident, you can
Mhm.
restore your data. I mean, your data are protected.
Okay, that's fine, no problem. If somebody asks you what is cloud computing benefit, the first and the top most thing that come to your head is that, instead of deploying infrastructure in your physical location, yeah, for example, you are going to buy like 5 to 10 devices and you will install software, hardware, and routers, switches. You are going to pay a lot of money. When we have cloud computing, everything will be sitting on the cloud computing. Okay, so this is how, like, if we talk about the budget, we are going to save like tons and tons of money with the help of cloud computing. And other than that, what you said is also correct, that we have scalability, we have these other features as well. And we will discuss about this in detail. We have another section for that. And what is IaaS?
Infrastructure as a service.
As a service, yes, that's fine. So that's great. And I guess you have a very good knowledge, both of you, on these topics. So this will be a fun when we'll hit these topics in detail. So let's talk about the first thing, what is firewall and the types. So if you take a look of this picture, this is how the firewalls will be look like. This is your inside zone or the network, and this is your outside, or you can say the public infrastructure. As the Crystal said, that firewalls is being used to protect, or I think the HIPAA also said, from inside to outside and outside to inside. So whatever the traffic that is coming from outside network, which is not secure, by the way, this public infrastructure is not secure. We cannot trust ISP. We cannot trust, from wherever the data go through or the packet go through, we cannot trust. So that is the reason the people sitting outside, they can, approach, and they can, take a control of your inside network. So that is the reason, the first and foremost thing, we use firewall as just to protect our information that is going from inside to outside and outside to inside. So if we talk about the real definition of this one, which I mentioned here, in computing, a firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. It means we have already defined some kind of security rules on the firewall to control the traffic. A firewall typically establishes barrier between the trusted network and the untrusted network, such as the internet. So he's saying that this is untrusted and this one is trusted. So when we will hit the ASA concept in the subsequent slide, you will see I will be configuring untrusted and trusted with the help of levels, security levels. These are known as security levels. So if I talk about security level here, because this is untrusted, I will give it security level 0. And since this is a very trusted level, I will make it 100. So this is how ASA will know which one of my leg is untrusted and which one is a trusted, with the help of these numbers, which is nothing but security levels, or sometimes also known as security zones. We have different kind of firewalls, by the way, because as the time elapses, the things changes, and network engineers and these IEEE, they have to jump in and to create some different things for us to protect from outside network. So like we have application firewall, and if we remember from our layer, OSI layers, we know at application layer, what things works like HTTP or HTTPS traffics. So this application firewall is very specific just to control these traffics, which is like web traffics or any other kind of traffics. If you are using application that is using these kind of information like HTTP or HTTP, so they can control these kind of things. So HTTP application firewall is specifically to monitor HTTP or HTTPS traffic. Then we have packet filtering firewall, and if we correlate it with the OSI model, and we know that packet layer which works at layer 3 packets, which has to do what? Source IP and destination IP. So from where the traffic is coming and where it is going. So this is the task of this packet filtering firewall. It has nothing to do with the application, by the way. So packet filtering is only concerned about the source IP and destination IP. Then we have a stateful firewall filtering that exists in the ASA firewalls as well. So what is it basically? Whatever the traffic, if I give you example from here. So let's suppose this PC wants to communicate with a website like jobskillshare.org. So when the request will be sent, okay, this firewall will keep this information its table, that from where source this is coming and which destination, like source and destination, which is where it is going. It will create a session inside it, firewall table. Why? When this job skill share will reply back, it will have a better understanding that this state is already exists in its table. So that is the reason it is known as stateful firewall, because it keeps the information. But opposed to that, let's say in that case, if some person is sitting outside and he want to reach to this, let's say this is a server. So this is from outbound, from outside to inside. If this state is not exist in its firewall's table, it will not allow. This traffic will be rejected. So that is the use of having stateful firewall. Then we have, the next gen firewalls, by the way, these days. If I give you example, this is like very advanced, but no problem. For the sake of knowledge base, I'm writing FTD, like fire threat defense. We have Palo Alto. Then we have like checkpoint firewalls. These are all, you can consider it like a next gen firewalls. And as you can see, they work from L3 all the way to L7. I'm talking about the layer OSA layers.
Sorry, I have a question. When you say Palo Alto, I immediately think of VPN client.
By the way, these all firewalls can work as the VPN as well.
So would you consider Cisco AnyConnect also a next gen firewall?
AnyConnect is no.
Yeah, Cisco AnyConnect is going to be like it's basically a separate feature that comes with that firewall. So AnyConnect is basically a VPN, but it can be added into that firewall package. So let's say, for example, when we talk about firewalls over here, we are going to talk about, let's say, ASA, which kind of like either it's like a hardware, right? Let's say we put two hardware devices in a company. One is the main, second one is the secondary, primary, secondary. So one is like the main firewall, second one is the kind of when the first one goes down. So in that hardware, it comes, that VPN type of packages come with that, because look, It works at the kind of like a door level. So if you are going to get into that company, you got to get through that firewall, right?
Right.
So it gives you that a capability to, you can install a VPN on those systems. So it's like a, on the back end, it's going to have like a package. Okay. When you have a package, you configure it, then you tell that firewall that I want to download a client from you because I want to connect through you. Does that make sense?
Yes.
But that connection and its checking and everything is what's gonna be the firewall. It's going to be doing that. So I'm going to fast forward this with the next gen type of firewalls. Now let's say, for example, 10 years ago, if I would have bought ASA firewall from Cisco and it came with hardware, let's say I bought it, right? So it also came with the capability of, let's say, VPN and stuff like that. I configured it. So when we talk about next gen now, and that's kind of a little more advanced stuff, it will have a capability to give me something more now. Let's say a module. We bought a module after, let's say, 10 years, the Cisco called us, look, you guys need to upgrade it or buy a new hardware from us because we have a new capabilities now. So when you buy that new hardware, it's gonna do certain things. Let's say, for example, it's gonna go to a new IP address and it's gonna be able to check traffic that the older version couldn't do. And that is what we call, when we say next gen, we're actually moving up to more advanced checking that the older versions couldn't do. Does that make sense?
Yes. Thank you.
Correct.
And after this, maybe I'll show you a little demo of an ASA, just real ASA, like how real ASA, and also a kind of like what advanced, ASA and what do you call FMC looks like. What does FMC stand for? I forgot, man.
What?
FMC.
FMC.
Cisco Fire. Sorry, I think it's Firepower Management. Console.
Yes, we have FTD and FMC.
Yeah. So
FTD is like the main from where the data will go, and FMC just the management console basically.
Yeah, management console. Exactly. So it's called, I think, Firepower Management Console, right?
Yeah.
So that is like the new naming, Haifa. When we talk about, if someone say, oh, go to we have Firepower, right? They're gonna probably have that interview question. So if you're gonna go over like network engineering jobs, most likely people are going to be advancing or going for little newer versions and not staying with the old version of firewalls, right? So you're going to start hearing these terms because a lot of people do use Cisco for this type of security, and many companies have ASA. So if they have ASA, it's more likely that they're going to be using Firepower to have a little new system in place in there. And he will show you it's even beyond that now. So it's not just internal firewalls. We have even Cloudflare firewalls these days that are in sync with your company's firewall. And we will kind of break it down to you in a few minutes.
Yeah, sure. So I also would like to add in it. Actually, Haifa, I want to put a line between the VPN and the firewalls for your better understanding.
If I understand correctly, VPN is like a tunnel.
Yep, exactly. It has
And the
nothing to do with
firewall-
the firewall. Even the attacker can encapsulated data inside VPN can send to the. So it has nothing to do with like protection. So basically, what VPN is doing, let's suppose you have this company here. Let's say we talk about the job skill share that is in New York, and then we have job skill share here in Pakistan as well, one branch of that. So if we want to extend the capability of this network all the way to the Pakistan, okay, because we want to communicate with this server that is sitting somewhere in New York, and this server or this user sitting in Pakistan, he wants to transfer or send the communication to this server. We do not want any person sitting in the ISP looking into this, what these packets are, or even if we want to access this server like a locally, it will just work like this computer is sitting inside here, New York.
Yeah.
Okay, so this is a concept of VPN, and you will be given one piece of information that is AnyConnect. AnyConnect is nothing, just it is giving you access to this local area.
Right.
Okay, and opposed to that, the firewall which I am talking about here, like if you want to control some policies or inbound traffic, outbound traffic, packet filtering, or next gen, what is it? I'm just going to explain right now here. So basically what next gen does, as we said in stateful firewall, it is checking like source IP, destination IP, in packet as well, source IP, destination IP. In application firewall, it is just checking, looking into the HTTPS traffic. But you know what happens? Let's suppose we have Facebook, and we want to block Facebook, but you know, I do not want to Facebook as a whole. If I give you just example, we have one chat applet from where, you know, you send the messages to each other. Like this is a message box.
So you can specify what to block from what side.
Yes, exactly. So this is just like the message or applet that is being used in the Facebook, and we just want to block this thing only, this. So with the help of next gen, because next gen not only take a look into the source IP, destination IP, HTTP traffic, but whatever the data inside, the data as well. In other words, the data also known as the payload. So whatever the, you know, the nitty-gritty detail inside this data, you also can take a look and can block or whatever you want to. So that is why they came up with the idea next gen firewalls.
Got it.
Then this is web application firewall that is very specific to the only web applications. And this is sandbox, and this is also very good technology, by the way. And what sandbox is, like we have this sandbox, inside it we have multiple operating system. Let's say we have Windows machine, we have Linux machine. Okay, then we have Mac or something like that. If attacker attack some kind of, you know, let's say he encapsulate its you know, information inside MP3. So MP3, let's say we know what MP3 is used for, and inside MP3 there is some kind of, you know, Trojan, a virus. Okay, so when it will hit this, let's suppose behind the sandbox there is a network. So this attacker wants to attack this LAN network. So before it enters, it needs to hit to this sandbox. And what sandbox will do, this MP3 information will run on Windows. Let's suppose if it is compatible with Windows, it will run on Windows. And now it will just de-encapsulate this packet and will check if there is a Trojan, and it will block here. But if this MP3 is belong to some Linux based, you know, this application belongs to Linux, and this Trojan is also inserted into this MP3 file, and this format only for the Linux. So Linux will come into play, and it will check if there is any kind of virus or no. So this is how, like, you know, we have like step by step, we have these defense basically. So this is known as sandbox. So got the idea? Any confusion until here?
So far, so good from my end.
Okay, that's great. So let's move to the next slide. So these are also related to the first slide, basically saying that many network security devices had been invented throughout the year to enforce policy and maintain visibility of everything is happening in a network. So following these are the well-known security systems. As you know that as the time moves on, we know that different kind of viruses and Trojan horses, these are being invented by the evils, and we have to mitigate those attacks. So to mitigate those attacks, they have to go through, first of all, these traditional firewalls. I talked about stateless firewalls. These are known as the stateless. Stateless. And this is the opposite of stateful that I, you know, talked in the first slide. And then they came up with the idea of next-gen firewalls. Then we have personal firewalls, like if you go inside your computer, you can see like AVG, Norton. Then we have some other defense mechanism like IPS and IDS, which has to do with intrusion prevention and intrusion detection. So, these all things are particular for some particular, mechanism. Like IPS, IDS, maybe they will be blocking attacks from some particular, from some particular evil attacks, by the way. And this is just like advanced malware protection. It has to do with the malwares attacks. Let's suppose this one has to do with the Trojans. Okay, so these are the different kind of sensors being used. Then we have these web security appliances. This has to do with just the web applications.
Yeah, and
So
think about it in a company, when at the help desk level, let's just talk about that so you guys can relate to it. When you have a machine, sometimes the networking team or your, admins will tell you, put this security agent or client on this device, let's say Windows 10, right? I'm sure you guys have done that. And usually it connects back to somewhere. So that could be either an internal server that is managing that clients. So that could be also advanced, malware protection, or it could be a cloud specific technology. Like for example, these days, Windows is very famous for Windows Defender. So you have this portal where people can monitor everything, updates, and you have this client, and then you just put it on the machines, and then it connects your normal Windows Defender and it makes it more advanced protection, and it goes back to the cloud. For Cisco, they call it Cisco AMP. It's like basically an advanced malware protection for Cisco. So they also have a client that goes back to the cloud. For IPS, IDS, it could be on the network level as well. So that firewall that we were talking about, ASA, could have different modules that can make it more advanced, and then it can actually do even that IPS, IDS, and even at network layer and network level, more of advanced protection. So that if you think about it, you need all of these basically right now. If you want to protect your company, right, or you were to get hired in a company as a network engineer, as soon as you go in, don't expect that you're just going to need to know security level of switches and routers. It's definitely going to be a mixture of these things that's going to make you an engineer, because you need to know all of these things at the basic level at least, so then you can get what is going on. So next, I want to just give you that tip that you remember, that don't look at it and then be scared of it. Oh my God, that's a lot of things. It's that every company will have their own products and they will have their own setup. So if you know at least the basics of these things, then knowing what to do inside the company is their job. They're going to give you the documentation. They're going to give you a good enough time to review it. And then maybe you can get into more deeper into these different sections and then get more advanced into it. So just want to give you that tip. So remember, when you guys are watching these, I don't want you to create that idea in your mind that, oh my God, these are so many different things that I need to learn. You just need to know that understand what's going on. And once you got the idea, probably practice one or two things, and that's it. You're good to go. Okay.
yeah, that's great. Thanks for elaborating, Danish, more on it. So these are different kinds of threat vulnerabilities and exploits. I just put this slide so you have better idea. So what is vulnerability? A bug, a glitch, a hole in or flaw in any network application. Let's say if we have Windows 7 and in the programming, when the developers they develop this program, maybe they left some very important piece of information left, they couldn't actually configured it properly. So that is the reason, the evils have very good understanding, and they can use the bug, and they can, like in exploit kits, if I give you the correlate with this thing, attacks on the selection of vulnerabilities. So this is kind of vulnerabilities attackers found, and with the help of that vulnerabilities, they can access your Windows 7 system. and they can put some kind of trojans, malwares inside it. So these are the vulnerabilities, by the way, and the exploits. Basically, with the help of these vulnerabilities, they can access these systems. So this is the difference between vulnerabilities and exploit kits. Then we have zero-day attack. If you ever heard about this, that the zero-day attack has happened to this system. So what happened, for example, if I give you the same analogy like Windows 7, when they deployed Windows 7, okay, and the attacker, they found these vulnerabilities inside this Windows 7 before Windows 7 developers know about it. This is known as zero-day attacks. So it is written attack against an unknown vulnerabilities with no known security fix. And by the way, if Windows 7 has already in the market, and before zero-day attack, if the developers of Windows 7, they do kind of configuration or do patching, this is known as the patching. So that's why when you install a very new Windows operating system, they always take you to the update setting, where you will update these all things. Basically what is doing, it is installing the patches. Any kind of misconfiguration will be mitigated using these patches. And then we have threats. It's nothing, just attack developed to take advantage of vulnerabilities. So as it's clear from that. And then we have these advanced persistent threat, the methodological long-term convert attacks using many tools to steal information. So attacker persistently or constantly just attacking to that same device, okay, just to get the information. It will use first tool. If it didn't work, it will go to the second one and third one, fourth one, and one by one. So with the help of those all the tools, he will be able to access the information of that device. So that is known as a advanced persistent threat. So this is I added the demo time for Windows Firewall. I will show you the Windows Firewall, which is also known as the host-based firewall. And if I take you to the back, the slide that I was mentioning here, this application firewall. So this thing comes under the application firewall. So if I can take you, can you see this run command?
No.
Okay, just a minute. Let me share. So I will just quickly open Windows Firewall so you can take a look at that. So can you see the Windows Firewall now?
Yes.
Okay, yep. That's fine. So everybody will be familiar with this thing, Windows Firewall. Okay, so it is mentioning here the private network and the guest network. Basically, this has to do with the public network. And this is your own. Let's suppose this is your home network. So currently it is saying that firewall defense is on, and this has to do with, let's suppose if you are in like airport or in cafe, you are using this Windows Firewall. So everybody will be allowed by default. If you go in detail, if I'll show you, click this one. And if I take you to the advanced settings, not advanced settings. Yep. Yeah, you need to click on this one. Turn Windows Defender Firewall on or off. So from there you can see the more detail about these private and public networks. Just click on that. Then you can see currently the Windows firewall is on, and notify me when Windows Defender Firewall blocks any app. Means if any app is coming in from your local area connection, if somebody is trying to access your own computer, it will notify right away. Okay. If somebody is coming from your outside network, and this has to do with the outside network or the public network. If somebody want to access, it will be notified as it is written notify. So you will get a kind of notification that somebody wants to access this application, whether you want to allow him or not. So, you know, the good piece of advice here, always when you are with your laptop and you are in a public network, in like on a hotspot or cafe, always check this option. Block all incoming connections, including those in that list of the apps. So, you know, there are so many people or evils when you are using hotspot in your public areas, they can access everything if this is unchecked. So this is the best practice. You just can block all incoming traffic from outside. If you said, okay, now you will see the guest or public. These are all incoming traffics are being blocked. Okay. Then if you go into advanced setting, no, for example, if you go into allow apps, there sometimes, you know, there's some kind of applications you install in your Windows, and you know, you have to give it privileges. Or if, for example, if somebody want to access that some kind of application from outside network and it is not being accessed, so you can come here and you can specifically, you can select that application from this allow another app, and you can add it, and then it will be added into this list. And then the same thing is here as well. This is private. So you can privately, you can access from your own LAN, you can access these applications which are allowed. And as you can see, most of the things are not allowed from the public. But as I said, if you are running some kind of, you know, different application from in your LAN, but you want to give access from outside network, you can come here. Sorry. You can come to this section, allow an app features through Windows Defender Firewall, and then you can add that application, and then you can, for example, let's say Skype, that as you can see, Skype is allowed from outside as well. But if you want, you can disable this one. So this is the thing that you can, you know, take into account. Another thing, if you click advanced settings. So that was the thing I was talking about, inbound and outbound rules. In ASA firewalls or Windows firewalls, or even the routers as well. So whatever the traffic is coming inside, like this is the router, this is your LAN, and this is your public WAN. So as the traffic hits this router, this is known as inbound rules or inbound traffic. As the traffic leaves, it is called outbound. Okay. So you can set some kind of rules here as well. So if, you know, very quickly, if I can give you example, let's say you can see the browser.
Yes.
Yes.
Okay. Let's suppose if we have one, you know, telecommunication company here, PTCL for Pakistan. If I click on this link, as you can see, I can reach this PTCL website. What in case if I want to block this one, what I can do? So the first thing, you need to go into command prompt. And now, this will be your revision.
We can see the command prompt.
You can see?
We can't.
Oh, okay.
I think it's on the back, maybe on another screen.
Sure. I will enable that. Now it's okay?
Yep.
Yes.
Okay, so the website that I told you about, this one, ptcl.com, it must have some public IP. So how to get public IP? And if we can go back to the module 2 or 3, we discussed that we have NS lookup. So PTCL, you just can copy this link and paste here. So it is giving you the information about the IPv4, which is this one. So basic idea behind this lab is I just want to block this website. So copy this information and go into your Windows firewall, and then you need to go into the outbound rules. And here we have these all outbound rules where our traffic is going. So right click on that and click on the new rule. And from here, rule type, select the custom. Click next. And then select from the all programs, click next. And this has to do with the protocol and ports. Okay, just leave it as it is. Any protocol, any port we want to consider. Then click on the next, and this is giving me the scope. So the scope that I want to add, just make it any IP address right now. And the block connection, no, just go back. You can add these IPs. For example, the one that I pasted from NS lookup, because I'm particularly I want to block this public IP. So click on OK, which is added. Now click on the next. Block all these connections. Next. And what domains you want? It means private, public, whatever, from wherever this public IP is coming, I want to block these all. Click on the next and just name this rule like PTCL block and give the description as well. PTCL is being blocked. And click on the finish. As you can see, the rule has been created. And if you can see, this is the local address going to any remote address. If you want, you can edit this one as well. Just right click, go to the scope, and you can add this scope as well. Means it will be like public and private both. I just want to give it information, the scope that it is either it is going from my local to outside or even coming from outside to inside. So I made changes, as you can see, the local address, remote address. But by the way, local address should be the source of your machine. So first, let's try this one. If it works, otherwise we will make changes into that. So this time, if I go to this one and I hit that PTCL, just a minute. If I can delete this thing, because this is in the history, so this could be the reason. And also I want to make some changes here because the local address is our source. So local address could be any IP addresses. The remote where we are going is the destination, which is the public IP of the PTCL. So click OK. Now this time, if I click again here, PTCL Pakistan, and if I'm searching for that one and click, and you can see your internet access is blocked. Okay, so I will give, once again, this scope rule because I got confused here. So this is your local IP, and we know this is your source. Source could be anything, and we know we are going to some specific destination, which is the public IP of your the PTCL website. Okay, so as you can see, it is being blocked. But if I right click and disable this rule, and if I try again, now you can see I can access the website. So if you want to delete this one, right click and delete this one. So this rule has been deleted. Okay, so this is for your outbound rule. As I told you, what outbound rule is, as the traffic leaves your traffic. Any confusion here? Yep.
No confusion with what you said, but I want to make sure I understand something. Let's say you have two of the same rule. All right, one is allow and one is deny.
Yep.
The one that is, so accidentally you made two rules of the same thing.
Okay.
But one is allow and one is deny. The deny one is going to be the master rule, right? Or the main one?
No, it has, when we will talk about the ACLs, just a minute, if I can come to the board. The fun part in ACL is that ACL always read from top to bottom. Let's suppose if I'm denying something, okay, and then I am, sorry, my mouse problem, just a minute. And on the another next step, if I am permitting the same traffic, what is going to happen?
Deny first.
Deny first. So it will never look into this one. So this is the rule of ACL. And by the way, in the next slide, I'm going to do that as well. Okay, so that was a very quick overview of Windows Firewall, and I showed you how you can block your, outside traffic. Then I told you we have one firewall that is known as the Stateless Firewall, which has to do with the ACL list, and this is how it will look like. You are creating multiple access lists, and the end of this, there is implicit deny. Means even if you will not mention this command, by default all traffic will be denied at the end. So these are very specific traffic. Either you want to permit or deny, whatever. If you don't mention this thing, in the end there is an implicit deny. I mean, it is blocking all traffic at the end. Okay, so I will give you the demo as well for this stateless firewall, and then you will have a better idea. So can you see packet tracer?
Yes.
Okay. So in this case, I'm just going to use one router, and I will keep it as simple as possible because otherwise you will be confused. And I will use two PCs. Sorry. And I will choose this automatic connection to make the connection between computer to router and then router to computer. So let's say the IP for this one is 192.168.1.1. And for this, we have 192.168.2.1. So these are both are on two different subnets. So we know from our previous study that if we want to make communicate between this computer to this computer, we need a router in between. So this is the router. So we will configure the router. So let's configure these IPs very quickly. Go to the desktop, IP configuration, 192.168.1.1, and then the subnet mask. Similarly, this one, desktop IP configuration and 192.168.2.1, and subnet mask is automatically appeared. Now in the router, just click on this router to go inside and click on the CLI, from where you will configure the brain of this router. So this the same system wizard we talked about. We do not want this, so hit no, and we are on a enable mode, user mode by the way, and we want to go into the enable mode. So as we know, we want to configure these interfaces. To reach these interfaces, we need to go into the global configuration mode, which is by typing configure terminal. Now I want to go into this fast Ethernet 0/0. So type interface fast Ethernet 0/0 and type IP address. Because this is from this subnet 1.1, so I will keep it in the same subnet. 192.168.1. Let's make it 100 for a default gateway, because I'm going to make this default gateway for this PC later on. And just type the subnet mask, hit enter, and write no shut. As you can see, the interface is in down mode. So typing no shut and enter, now it is up. So we can see from here as well, the link is up. Now we need to do the same thing for fast Ethernet 0/1 as well, but on a different subnet, which is for the 2. So 192.168, sorry, IP address 192.168.2.100, 255.255.255.0, which is the subnet for that. And do it no shut here as well. WR to write the configuration. So you know the label here as well. 192.168.1.100 for my left side and 192.168.2.100 for this network. So this is how, you know, if you label these everything, you have a better understanding from where you are moving to which destination. So at this moment, if I try to ping my default gateway or even the interface of this router, which is directly connected, and we know that it is directly connected, so it will be a pingable. As you can see, I can ping. And we discussed in our, you know, the last session that if I want to ping this leg of this router, I can, because this is on the same router. So this router has information about this one. So if I try to ping 2.100, and I guess the problem is, yep. Yeah, so Krista, can you tell me very quickly why it is not pinging right now to this? I'm coming from here and I try to ping this one.
Yeah, it should. It should. Because it's a router.
Mm-hmm. Okay, but you remember in the last lecture, we tried to ping and it worked.
Can I see the setting for that interface, please?
For the router?
Yes.
Okay. If I do show IP interface brief, you can see, sorry.
Yeah, I can see.
Okay, that's fine. It's not expanding, by the way. So this is for your fast Ethernet 0/0, which is 1.100, and for 0/1 we have 2.100, and it is up and up. So it means it is in a good state, by the way.
Yes. So do we have to do IP route or no?
For
see
where we will do
directly
IP
connect.
route, where we will do
IP route?
On a router?
Yeah.
Okay, that's fine. And Haifa, if you can also add some into it.
Sorry, I'm slightly confused.
Okay, no problem. So the problem is, the problem is we haven't mentioned about the default gateway. If I go to IP configuration, as you can see, it only knows about this one network. And I told you, if my computer wants to communicate with two networks, it has to go where?
To the gateway.
Default gateway, which is what? Which is 192.168.1.100. Got it?
Good.
Okay, so this time, if I try to do the same thing, it should work. And you can see it is working. So this is, I know this is a very confusing area, by the way, but you need to figure it out. So same way we will do here as well. IP configuration, and we will do 192.168.2.100, which is the default gateway for this one to this. Means if this computer wants to communicate with this computer, which is on different subnet, of course, it will compare with this subnet with its own subnet. And if it is not matched, it will blindly send to the default gateway. Okay, so even from here as well, if I try to ping, first of all, my default gateway, which is 2.100, I can ping, and the other leg of this router, which is 1.100, and I can ping, we know that. But if I try to reach 1.1 from here all the way to here, what do you say? Will it work or no?
It will work?
Yes.
It will work? Okay, well, let's try.
Yes.
And from here, if I do, just a minute, first confirm IP config, ping 192.168.2.1, as you can see, it works. Because the router now have the knowledge about both legs. Okay, they know about the two network. Now they know about the one network. And from here, this computer knows that if I don't know about this two network, I just need to send to this router default gateway. Got it? Any confusion here until here? Any confusion?
Nope.
Okay, that's fine. So what we were talking about, we're talking about the ACL, access control list. So what is the scenario? I do not want this computer to ping this computer. So first of all, confirm. Let me close these things. So so if I ping 192.168.2.1 and we are confirmed that we can ping. If you want, we can do trace route. I think this is a command here, 192.168.2.1 or tracer, because packet tracer is a little bit different. Yep. So with the help of using the tracer command, we know that First, it hit what? The default gateway, which is this one. Then it went to 2.1. Then it hopped using this interface to this one and reach its destination. So the criteria is I want to block 1.1 pinging this device 2.1 using access control list. So click on this router. Go to the configuration terminal mode, because this is the global configuration. This is global command, by the way, access list, and type access list, and then you will see two kinds of access list. One is known as standard. This is also considered like STD, and XTD, which is extended. Today, I will just discuss about the standard access list, not extended. Otherwise, you will be confused. And by the way, in CCNA, we have, a complete ACL lecture just on the ACLs. And we will be working on ACLs a lot in detail. And if you remember, we also use this ACL in the lab when we were doing a NAT. If you can recall, you remember if we were using ACLs in the NAT configuration as well. So these standards are from 1 to 99. And your router is intelligent enough. If you will type ACL command and will give the number like 1, it knows that it's talking about the standard access list, which is very basic access list. Extended, we can go further, dig deep into that. And if we want to block some like HTTP traffic, if we want to block some telnet traffic, if we want to block some other SSH traffic, something like that, we will use extended list. For the standard, this is just like layer 3 ACLs. We are just concerned about from source, from which source it is coming, and which that's it. It will not talk about the destination. In extended, we have source and destination as well. But the standard access list only know about the from where the traffic is coming. Okay. When I will configure, you will know about it. So access list, let's take first one, because I want to configure the standard access list. And what I want to do, deny traffic or permit traffic. Let's make it deny. Okay, what is the source? It could be any, or could be single host, or you can define the subnet as well. For example, if we have multiple computers here, and I don't want to specifically block this only host, I want to block this whole this subnet. So I can be more, I can use 192.168.1.0, which will represent this whole subnet. If I want to be more specific, I can use like 192.168.1.1 for this traffic only, but these will be allowed. So in this case, let's make it like the whole subnet. Okay. So for that, what you can do, 192.168.1.0, then space and put question mark. And you remember we talked about the inverse mask. This is inverse mask, wildcard bits. The proper subnet is like 255.255 .255.0. But wildcard is inverse of that. If that is 255.255.255.0, inverse mask will be 0.0.0.255, which means in wildcard, which means look into these things. Just keep eye on these things. These are eyes, by the way. So I'm looking these. So I'm interested on these things. I don't care whatever comes after that. So this one is don't care. I don't care about this one. So here we are more specific, like access list. I want to deny this whole subnet. So what could be the wildcard for this one? If somebody can tell me or guess.
0.0.0.255.
Yes, because I'm only concerned about this network, this octet, this octet, and this octet. Whatever comes after that, I don't care. So it means I'm going to block this whole 192.168.1 network. Okay, and then do, and that's it. This is a very simple, and hit enter. So you have created one access list, which is denying this traffic. After that, whatever comes after that, I want to permit. Access list 1, permit any, and that's it. Means if we have some other subnets like 10 network, 172 net subnets, they will be allowed after that. Because I want to just block this subnet only. If you want to see your configuration, go show access minus list, and it will show you whatever you did. And I told you after that there is 30 with implicit deny. Implicit deny means whatever comes after permitting will be denied. But you know, I am doing permitting everything, so that's why I know it will not go after that. But if I will not mention this one, here will be implicit deny. It means if I am running 172 subnet here, and then let's say 10 network here, these all will also be blocked because of this implicit deny. Okay, now we need to apply this access list where on this interface when it is traffic is coming inside. So how we can do that? We need to go into fast Ethernet 0, and the command is basically access. Sorry, not particular to this interface because these are global commands. So we need to go into access. Just a minute. That is totally different. You know, when you are configuring as a global ACL, you will do access list. As a globally. So this is the global command. But if you want to deny the traffic specifically for this interface, you will go in that interface and the command is little bit different, which is start with the IP. So you also need to take this into account. Many people, you know, get confused, like I got confused. So this is a command is IP access group. What is the access list which I mentioned, which is number 1. You have to mention this one. And it is saying what is the flow of traffic, as the traffic coming inside or it is leaving this traffic. we know that the traffic from here, it is coming inside this interface. So you need to go API access group 1 as it come inside and hit enter. And that's it. So now this access control list has been enabled on this one. This router will be looking into this subnet. As it hit this interface, it will block. Let's do it. So we need to go into this computer, go to the command prompt, and we can see the last time it was giving me replies. So let's try this one, ping this one. And now, as you can see, the host is unreachable. It means our access list is working. So we cannot reach this destination anymore. Okay.
Now this could be done on a firewall too, right?
Yep. The same method we have almost.
Yep. Okay. So are you guys getting this whole concept of like how you can deny things from different levels? Like routers can do the same things. Firewalls can do the same thing. Or even when a single device have firewalls, is the firewall concept getting clear to you guys?
Yes.
Yes.
Okay, that's fine. This is known as stateless, by the way, because it doesn't keep the state of this ACL information inside table. So it is just looking into the source. That's it. And the other one is extended, that will take a look of source as well as the destination, because we can be more specific. We are going from 1.1 to, let's say, 2.100. We want to block just that flow. That comes in the extended list, and that we will cover in a ACL CCNA topics. So let's talk about the ASA firewall as well. And I just I thought I should give you the demo on that as well. Or shall I keep it for the last, Danish?
Once you finish with the whole firewall, then I will be taking over to just show them how real companies and real system looks like. Just to
Okay, so shall I proceed with the demo, because I don't want, because we have already done 2 labs, so I don't know whether they will be able to digest.
Are you going to use packet tracer for this?
Yep.
Okay, let's not do that for now. I want to keep this later on, because I want them to first see how the GUI side works and to understand what firewall ASA looks like.
Okay, that's fine. And that's great, because otherwise it will be so dry, we have already gone through.
Let me take over the screen over here. So what I'm going to do, Haifa and Christelle, I'm going to show you how a real 2021 we were talking about, how if you were to become a network engineer right now, apply for a job right now, and how does it look? I'm not going to do demos over here. I just want to show you real systems to just give you now practical example of what you have learned so far. So let's get started with that. And I'm going to share my screen. So go ahead and stop sharing your screen, Kamran. And
okay, that's fine.
So are you both here?
Yep.
Yes.
All right, Haifa, are you here?
Yeah. Can you hear me?
I can hear you, so but I'll continue. Okay, can you see my screen?
Yeah.
Yes.
All right. So going back to when I was actually doing training with Haifa, I told her that my drawing is the worst drawing ever in this whole world. So first, I'm gonna do that announcement quickly. So whenever people see
Picasso.
yeah, they should see that, right? So, okay, you both know that we have, let's say, a company. This is a company we're talking. This little company is basically our company right now. Okay, so we're gonna do this. This is a company. And in this company, let's say we have a firewall. So you apply to this company right now, you went in, you talk to this manager, and they say we're using ASA firewall, and we have a device that's running inside our data center. It could be like, it's like a Cisco device. So when I say something like that, do you know back in your head, like, okay, this is like a hardware? Do you know anything about it? Like when I say it's a device, it's what comes into your mind? It's like it's going to be like a Cisco switch-like device, router-like device, like that, right? Like physical thing, right? From
Yeah,
Cisco.
physical. Mhm.
Physical. Okay, that's good. So when we talk about that, and let's say this is the company, they have devices, and these are clients. These are like your endpoint devices. These are the desktops, laptops inside that company, and they're directly connected right here, like in the system, like in this whole building. They're not outside right now. Okay, these are directly, Ethernet is connected to it. So the one thing I want to remind you how important it was in the beginning of Kamran's lab, before he even went to ACL, where did he get stuck? Or where did he made you guys think, why was it not working? Why is the ping not working? So
Firewall?
No, not firewall. Because the reason I'm reminding you guys is that before you get into ACL, and for all of these things to work, what is the main thing that's working over there? Networking. Just the basic networking has to work over there, right? For it to ping, for it to connect with each other, right?
Yes.
Yes.
So this is a reminder to anyone who's listening to me right now. You cannot jump into firewall learning in a very advanced learning and think you're going to learn this stuff without knowing networking. That is why we do this networking training. If you're going to get into deeper and deeper into these firewalls, you got to understand how networking works, because without that, you will not understand 50% of what it represents to you. So that's the number one thing. So this hardware is right here. When we say it's an ASA, or we talk about ASA, things like that, in reality, it looks like this. So it's like a real ASA is right here on the left side. This is an actual hardware running, but since there's no like GUI right now, this is like just like a router, right? So like a switch or router type of access. So you can get into this and configure this. But if in a let's say, for example, for you guys, if somebody say we're using ASA and they say log into the ASA, as a junior level, I don't expect you to know too much of a CLI, but still you should know the basics, right? So now let's say you know the basics of that. But when we talk about getting into ASA, it's like this, ASDM. This is the software that comes with ASA. You have to configure that. You have to like go to the IP, download it, run it on this machine, and then you double click on it. And that ASA in that company, then you say, okay, as a network engineer, I know what this is. So the reason I'm saying it in this method is that I'm giving you an idea or a tip. So next time when you are finished with this whole lectures, I want you guys to do some research and find more about learning about these things, right, on your own, because that's what's going to matter. And if you look at you guys are also members, so you guys should have practice lab access. So you can ask me, what lab are you using? And I'll tell you later on, okay? I'm using this lab, and you guys can do the same practice if you want. So I'll log into the ASA right now. I'm going to go ahead and say yes. How did I log into this? Because my hardware is running right now. If my hardware was to be turned off or some issues, I won't be able to do that. So again, what is working over here? Networking. It's working because I can get to that ASA because networking is working. So again, a very important piece that I'm keep pushing right here, that you have to know that stuff first. So if you look at it right here, this is how a firewall looks like. This is a firewall that is used by many, many companies out there in the market right now. And ASA is a well-known product. So if you know about ASA, you can go to any job. And if they talk about firewall, and if you say about something about ASA, this person is going to respect you, whether they use what are some other firewalls? What is the name of Pablo Alto? What I even forgot.
Yeah,
Palo
Palo Alto.
Alto.
Yeah, Pablo Alto. Okay.
Pablo.
So then there are many other Sophos have their firewalls, so many different type of firewalls out there, but ASA is pretty well known. That's why I want you guys, if you have the capability to get your hand on something like this, which is so real, I want you to do that because tomorrow when you go to the interviews, you know how to handle this type of questions. And because now you have visual access to this type of stuff, right? So here, when we talk about, when he was talking about ASA, and you know, how do we do things on an endpoint, he was blocking things on a network level. You have like, you can block things at the network level. So none of these devices that you have internally in your systems right here, they cannot go out, or they can do whatever you want them to do. You can control it from here. Where? From here, right? Just one single point. You control it from there. And all these, if you want them to be going out, then you can have them go out. If you want someone to go inside of these systems and get to it, you can do that. So that's the point of having a more of a network level firewall than a single computer based firewall, because then you're not going to each computer try to configure it. So it's good for management. It's easy for management, right? So if you come to this firewall, I'm not going to go into the ASA learning right now, but you can clearly see that there's some data going on. There's some up devices. If it was down, you would have known from here. On the bottom, you can see there are some logs going on right now. Some messages are going on. And if you go to the configuration, this is where we are talking about different type of configuration, even inside this firewall. So coming back to Hefa, your first question, what about AnyConnect? You can set up an AnyConnect on ASA like this. I'm showing you right here, VPN, Wizard, and AnyConnect is right there. So I'm going to click on it. And if I want to configure AnyConnect, I'm just going to configure this whole thing. And this is where the engineer, you configure all this stuff. And a help desk go to what? A link that is given to them so they can install an agent or a client that is coming from this ASA. Does that make sense to you now?
Yes.
So when a client will connect to a VPN from outside, it goes through this configuration, connects it, and then you have that information over here, and you can monitor things. And it's under this whole firewall, so you can actually then monitor things and do whatever you want to do with this firewall. Okay. So if we go to the firewall section, you see we have those things that Kamran was talking about, ACLs and everything like that. So if you were to set up rules and things like that, we will click here, add. But in firewalls, it's smart. It has more capabilities, so you don't have to go through a very manual process. So let's say if I want to deny something, I'm going to say deny, and we use services over here. So if you come over here, you see ICMP, those are the pings one, right? If I want to do IP addresses, if I want a TCP, if I want an HTTPS, HTTP, there's so many different type of services that we can do over here. So yes, we use this. And if you go to the companies, what will happen? This will be done already. You're going to have a big list of rules out here. So imagine if you were to become a network engineer and you just got a job right now and they say we are using ASA. Isn't this going to be a problem for you if you don't know ASA? Because now your whole work depends on how things access. So if you were the engineer and everything has to be managed, any other devices, any other access, it's actually running from that level. So if you don't know it, then you're stuck. And that's very important for you to come back and learn these extra things with your networking, because no one's going to just hire you that because you know routing or switching. People are going to hire you because you know how to manage network. So this is important. So that now coming back to visual explanation, this is a company right now. We already talked about VPN. We're going to remove that because that's not a part of this thing. So let's say this guy, the CEO of this company, say, you know what? It's been 6 months. We are using ASA. There's some new technologies now, and people are using that. And people are not using this old way of logging into these firewalls. So then you say, you know what? Okay, yeah, let's call Cisco, and we're going to add a new hardware, or maybe something inside this ASA. Maybe it has a module or something like that, right? So somehow you worked with Cisco and somebody configured this whole thing. You call them, you work with them, vendor, whoever that is, you configured it. Okay, so you went to this company and now they're saying we're using ASA, but we're actually using a little modern, firewall technologies these days. So you're gonna be like, okay, what is that? We're using FMC. So for that, I'm gonna take you right here. So if you look at it here, right here, this is going straight to a FMC right now. But if you just look at it, right, Hefa and Christelle, isn't this a little modern way of looking at firewall than the first one?
Yes, much.
You have
It's-
threats, you have intrusion detection, you have
Wow.
events right here.
I feel like this is more user friendly.
Yes, it is. And if you look at it, it tells you exactly, then even in detail, like what kind of applications are using the most bandwidth. Microsoft Update, SCCM. There's a different type of, oh, look at this. We have this protocol that's just came out and it's actually in use right now. Okay, so SMTP, Chrome, you can come and see things right away as a network engineer who is messing with my network. If somebody was to use a lot of bandwidth and people complain about, I cannot do anything because our system is slow. In this level, you don't have too much. You're gonna go to the home. You're probably gonna go to the logs over here and try to figure things out. Let's say you go to monitoring here, and here maybe you may go to the properties, and then you're gonna come down and you know what? I'm just gonna click on connections here. So okay, this is a pretty good way too to find, okay, which machine, which IP address right here, which IP address is hogging my network, so I can clearly see what's going on over here. Same way, the new versions, the new firewalls or new systems have a little better way to tell you which machines, which protocol, which application. It has a little more control over these things. Does that make sense?
Yes.
So in a company like that, they will have something like this implemented, and then they can kind of like control things on a network level. Again, I am on a network level. I didn't mention anything about how to manage a endpoint devices yet, right? So how does that work for on an endpoint level? Right now, currently, the current trend is that you have a cloud company, like let's say a Microsoft, right? Or Cisco also have a cloud version of protecting your environment. So if Cisco is using AMP, advanced malware protection, then Microsoft is using what? The Defender, right?
Windows Defender, yeah.
Yes. So if I was to go for Cisco product, then I'm gonna go and buy a Cisco, subscription. I'm gonna log into their console, and from here, I'm going to say that I want to basically manage my endpoint devices. So it's gonna go through your network. You have to do something in your network to let it go, and you have to whitelist a lot of things, and it basically connects to the AMP, which is Cisco. Your headache is gone because these guys are way better security professionals than a normal network engineer who is not a security person, right? Because they have experts sitting right here trying to make this product better and maintain your updates and threats and things like that. All you have to do is to get the agent, install it on this device, and now what happened? You can be anywhere in the world, you can connect to AMP, and now you can control your devices, what's going on. So in terms of Microsoft, if you say, I don't want to go for this solution, I want to go for Microsoft because this is a Windows operating system, it may react to Microsoft product better, then yes, there is a possibility you're just going to go straight like from your firewall to Microsoft, and now you have a better solution. So how does that look like? I'm going to show you that here. This is an actual system, E5 from Microsoft. We use security right here, and all you have to do is to go to the security, and then you can see that you can get into these systems like very advanced stuff over here. Okay, so I'm gonna go to the security right here. It's probably gonna take some time to come up. All right, so look at this. All of these systems, this is actually a real system that I'm showing you guys. So these are all devices. These are all like, where is it connected to? Risk level is what for these two machines?
It's high.
It's high. So the point that I'm making over here is, look, in just 5 minutes, I told you that we are using different systems to manage our network. So as a network engineer, open your mindset to this, that I have to learn different technologies, because that's how real companies these days in this environment, they're working like that. And on top of that, if you have a websites running, which is a major thing in the company, I feel like you're going to become a network engineer and there's no way you're going to get away with this, because every major companies, every normal companies have websites or products or something to be out there, right? Memberships, right? So they have websites, and how people manage websites. These are, so coming back to the web application firewalls. So you may be also involved in learning some type of other technologies that you have to manage your websites and applications running inside those websites. And what am I talking about? I'm talking about, let's say, an example of Cloudflare, which is a very big company and a very well-known company. So you got Cloudflare, if you want to learn about, you got ASA, you got some of the advanced things like, let's say, Microsoft Endpoint for like you get a trial subscription. So you got these 3 products on your resume. And that's the whole point that I'm making over here. If you have these 3 products on your resume, I will respect you when you come to my interview, right? Respect as in I will know that you know your stuff and you're compatible in 2021 to manage my company. Does that make sense to you guys? The whole point,
Yes.
the whole point that I'm making over here is how you can use different well-known products to impress the other person to give you this engineering level job. So if you look at this right here, we're also looking at firewalls, but this is a firewall for what? Website. So how many times my website almost got attacked, or my website says that I need to challenge you? How many times did that happen in last 24 hours?
1.62,000.
Yeah, and how many people that it blocked automatically? 13. If you don't have systems like this, it's really hard for companies to even work these days. And especially when they are a company where they have to charge people online for products or something like that. They will get attacked like 1,000, 600,000 is nothing. You're probably looking at 10,000, 15,000 attacks every day.
Wow.
So imagine if you were to get attacked like this from an IP that changes immediately, changes after 2 minutes. Would you be able to do that on a firewall level? Like, would you be able to come over here and try to put an IP block? Can you do that?
No, that's too much. No, it's not possible.
It's not possible, right? You got to come up with something more advanced on a network level. Yes, this may protect you a little bit of the FMC level may protect you a little bit of that, but even beyond that, we have now cloud controlling our networks. And if somebody hit our network, this is what's happening. Another company hide your company, and then they are in the front line and they block all of this stuff. So it takes that whole headache away, because I know for sure, and bring any engineer right now and ask him 5 or 10 years ago, how do you feel about the DDoS or DOS attacks? How do you feel about that? And the person will say, man, I'm about to cry right now, because it would happen and you would sit there and you would try to do everything manually, right? You would try to defend your network and you have to do this manually. But now you have this type of company. So why would someone not go for it? Because people are losing money. So yes. So the reason I'm making this, the point over here is, again, if you want to land a job, you have to add external learning like this on the side. And I'm not trying to say that you should get away from your learning right now, because you're in a network plus only right now, right? So I have given you an idea now. Now, slowly, you need to pick on certain technologies and you have to refine it, or try to at least come to a point where you can talk to a manager that I know this stuff. So I hope with this visual, I made some sense to you now that why all of these things are important. Okay, any questions?
No, that's straightforward. Thank you.
All right.
Thank you.
Kamran, you can take over now.
Okay, thank you so much, Danish.
Please, Danish, don't forget to give us the name of the lab.
Yeah, sure. I'll definitely give you the lab information. Kamran, are you sharing screen?
Yep.
Okay.
Yep. There is some kind of lag, basically. I don't know. Can you see? So, okay. So since the ASA is covered by Danish, so I will proceed with the voice over IP. This is also the technology, and we are all familiar with this on day-to-day basis because we are using this almost every day. So what is voice over IP? Voice over Internet Protocol, also called IP telephony, is a method and a group of technology for the delivery of voice communication and multimedia over Internet Protocol networks. So we know that before we were sending the data over IP, but now we are sending the voice as well. So that is the voice over IP. It used, as the Crystal said, that it used the kind of protocol that is SIP, and it also used SCCP, which is known as Skinny Client Control Protocol for the communication. And the session, as it is mentioned, the session initiation protocol is a signaling protocol used for initiating, maintaining, and terminating real-time sessions that include voice, video, and message application. SIP clients typically use TCP or UDP port numbers. These are very important if you can remember. These are 5060, which is clear text. Clear means if somebody, some evil person is sitting in between, and if he tap that information, it will be in a clear format so he can listen everything. The other port it's using is encrypted, which is basically the TLS, which is 5061. So whatever the communication will be happening, it will be like encapsulated. So nobody, even somebody will capture that packet, they cannot read whatever inside it. And this I have also mentioned this attack, which is known as the vomit attack, voice over misconfigured internet telephones. What it does, it converts a Cisco IP phone conversation with the help of TCP dump into a wave format. Okay, so they will
can we call it a ghost attack?
Yep, ghost attack as well. Yeah. And then they can play with any audio, player, so he or she can listen whatever you are saying on phones. It use kind of codecs. I'm using these vocabularies. So, if somebody is talking about SIP, SCCP, codecs, you must have an idea they are talking about voice over IP. So codecs is nothing, just, the technology that determines the audio quality, bandwidth, compression. Sometimes you want to compress whatever, the communication is going on. So this is the, with the help of codecs, you can do that. As it is mentioned, it does compression and decompression. So that is no, yep.
I have a question about vomit. You said that you recorded. So if it is encrypted, can it they can do nothing, right? Even if they record.
Yeah, if they are using this, let's suppose 5060.
Okay.
Okay. The TCP, they are using TCP, but 5060. So just like a Wireshark, even the Wireshark has ability, to capture the voice over IP communication, and they can convert into this web format, and then you can listen whatever is going on. So that is the reason 5061 is being used as a TLS. So whatever the communication will be there, it will be like encrypted. Okay. They can capture the packet. It is not like they will not capture. They will capture, but when they will like de-encapsulate or will try to find out this audio, they will never be able to listen that one. Okay. Then this is just the old topology. Basically, we have these PBX we were using in old days, which is stand for private booth, public exchange, public branch exchange, basically PBX. And these are normal old telephones. Whatever the communication, it go through your voice gateways, and it is using public infrastructure, and then it can hit the destination. So that was the old technology. So since the Cisco came in, they came up with the new ideas. The voice gateway is almost same. Okay, but then they have these kind of things, that's CUCM. Okay, and this is our LAN environment. If they want to communicate the other end, they will use Cisco specific IP phones and Cisco specific UCM, CUCM to communicate the other end. So if somebody want to migrate from this old infrastructure to the new one, they just need to replace this local infrastructure. Basically, they will not touch this infrastructure because that is almost same. So when we talk about voice over IP, as I said, we have these two things, which is this one is basically this thing. CUCM stand for Cisco Unified Communication Manager, which is enterprise call control and session management platform that connects people anywhere using any device. So this is how basically if you want to communicate, it will first of all send the communication or get the communication from this, and sometime there has a FTP as well. For example, these all phones has kind of some configuration, and they are taking from where? They will take either from FTP or CUCM. Okay, then they have to send this to traffic where? Of course, CME. So that is Call Manager Express. So it is like a gateway. The information will pass through this one, and you can communicate with the other end.
Now, just for clarity purpose, Kamran, maybe you can correct me. I don't have too much knowledge on this side.
Okay, no problem.
When we talk about these things, when he says CUCM, CME, some of these things are kind of like VMs as well. So we're talking about virtual machines. When they create virtual machines, the configuration is done on there. It's like a operating system. You install it, you do all that kind of configuration, and then at back end there's another hardware there. Again, we were talking about hardware, right? It goes back and connect to it, and then you have all this configuration. Like you can, just like when I show you about ASA, right? There's a hardware, there's a connection. When he's talking about these different type of SME, CUCM, that's also the similar type of setup from Cisco that we're talking about here. But just want to remind some of you that you may land a job in a company. So let's say you're all in one what do you call all in one man IT shop? That's what we call the name, right? When somebody's alone and you're the only network engineer, then yes, you may need to know these things. But when you go to like a mid-sized company, most of the time you have different type of skill set from different engineers. So one would be more of like a voice engineer. You may be more of a networking guy with a different type of skill set. But do you need to know this? Yes, of course, because if let's say the other engineers are on vacation and somehow you lose a connectivity or your system went down and it has to come back up now, something happened. Because what happened in this type of setup, as far as I know, you have to run some type of sequential restarts in this CUCM type of setup. So you have to understand what that is at the very basic level. So maybe this is something we will touch in the CCNA at a more visual level. I told Kamran that we may come up with something for this, okay? And later on, and today, just kind of know that there's also a voice setup and we have phones, and how are they connected is what I want you to understand from today's lecture. Like, what is this? How are they connected, and why do we use it? That's kind of like the main concept I want you to take out of this whole what he's teaching. Okay.
Yeah. So if we move on to the next slide, as Danish was talking about the software, as you can see, if we talk of the endpoints, this is, by the way, infrastructure model. If we talk about the endpoints, what are the devices that are connected to your endpoints? Just like a computer, we have IP phone, wireless, and then you can see IAM clients as well. We have, that software is configured. Instead of having IP phone, we have some kind of softwares installed on these laptops or computers. Then with the help of these handsets or headphones, okay, you can make the call as well from your laptop directly. So these are the things that comes at the endpoint. Then we have at the application level, we have like configured like voicemails, conference calls, call center, 911 services. Usually when you make a call, you will listen a kind of voicemail or something, call center applications, they have pre-configured some voices or recording in that. So these are the applications. These are the call processing, as I said earlier, that CUCM and UCM, these all are comes under the call processing. And then these are the normal infrastructures like the voice gateway, as I showed you in the last slide. Sorry. Like these are the voice gateways, basically. So these are all the pieces that, you know, combine together to make one infrastructure. So you do not need to remember, just, you know, for the sake of knowledge and information, you just can have idea. If you are more interested into this voice over IP, what you can do, you can type unified communication manager. You can go a lot in detail what it does. UC 500, what is the difference, if in case if you are interested. So I have planned to give you the demo as well on Cisco Packet Tracer. So because you have a better idea what Cisco Packet Tracer can do. And it's Cisco Packet Tracer, we consider it like, you know, the very basic level software, but, you know, it is quite capable of doing everything. Even when we will hit wireless LAN, you will see we can deploy wireless topology on that as well. So I will take you to the Cisco Packet Tracer. And just, can you see the Packet Tracer?
Yes.
Okay, that's fine. So let's make a very simple topology, and some of the configuration like I will hide from you, or I can share as well with you, that is to do with that IP telephony. So you don't need to worry. So you just take the process, just, you know, take a look how I go through, and then you can follow what I'm doing. So just drag and drop one switch, and then take one router. This router, just you can consider it like CUCM or the FTP as well, if you can. Means whatever the information your IP phone is gonna get, it will get from your this CUCM or router. So we have very simple topology, router, switch, and then add one IP phone as well. As you can see, we have multiple phones here. These are normal phones. This is voice over IP device. So not to confuse with this one. This is the one we are looking for, IP phone. Just drag and drop it. And then just double click on that to, if I can give you the visual of that. And just zoom in. So this is the back of your voice over IP device. This has to do with the console. If we remember, we talked about the console. It is also known as RS232. Then we have these two ports, Ethernet ports basically. And this is, if you are connecting this phone with the switch directly, then you need to connect into this switch port, or in some scenario, you can have here PC as well. PC will be connected to the phone, and then this PC will be connected to the switch. So in that case, you can use this one, which is written PC. Okay, so this is a back, and then this is the power adapter. You can just drag and drop and plug into it to turn on this device. So if I go to the GUI, which is stand for graphical user interface, if I will click, you will see it will give me the error device must be powered on. So I told you from here, you need to just drag and drop into this. This is the thing, basically giving it power. So it is connected now. Once you will click on the GUI, now it is working and it is not giving me any error. So this is the front. So nothing you can do here more, because this is, you know, the simulator. Just if you can just click these buttons and something like that, and click backspace from the keyboard to remove that one. So very quickly, let's connect this device with the switch, and this switch with the router or the CUCM. So from here, we are already familiar that this is the access port, but we want to assign this as a voice VLAN. I know from our previous lectures that this is by default on a VLAN 1. So whatever the communication this phone will do will go through this VLAN. Okay, but we know that this is voice VLAN. This should be under the voice, not data. This VLAN is for data traffic. And this, whatever I'm going to configure after that, will be for the voice. So let's very quickly jump onto the switch and configure this port as a voice VLAN. So we should be familiar what interface this my phone is connected with, which is fast Ethernet 0/1. Just click on the switch. Go into the switch, enable, configure terminal, and we need to go into the interface fast Ethernet 0/1, and then there is a command switch port access switch port. If you don't know something about that command, just hit question mark, so you can dig deep furthermore. So as it's mentioned, voice switch port voice, then VLAN. We will associate this interface to with the voice VLAN 1, and that's it. As soon as I hit enter, you can see now it start negotiating, because I made this interface the part of voice VLAN, which is just for the voice. And if I will not mention voice VLAN, it is become the part of data. Okay, so there is a distinct between voice VLAN and data VLAN. And since we are here, we are on fast, we need to go into fast Ethernet 0/2 and also make it no shut. That's it. Interface fast Ethernet 0/2 and just type no shut. So as you can see, it is not up right now because we have a router. We need to make this port up as well. So very quickly save the configuration, type writing WR and then close this one. Now we need to go into the router. Go click into the CLI. As you can see, it didn't find the system configuration, or that's the why it is showing me the wizard. So we want to configure, do our own configuration. So that's why we will type no, go into enable mode under configure terminal. First of all, change the name of this router because we know that this is CUCM. So with the help of host name, CUCM, and now you will see, notice that from router, it went to the CUCM. So I'm just giving it a name. So, when somebody is logging in from console or SSH, telnet, so he have better idea where it landed. So very quickly go into fast Ethernet 0/0 for router, make it no shut and give it the IP. Let's make this all subnet into 192.168.1.0. So IP address for my CUCM will be, let's make it 192.168.1.100 with 24-bit subnet mask. That's it. So this voice over IP phone need to know the information, like what is the number of this phone, or whatever, the ringtones, these all files, it is gonna fetch from where? From some place, which is this CUCM router. So this will act like a FTP server as well for this voice over IP phone. So for that, I will open my notepad as well because I have configured everything ready. So without wasting any moment. So can you see the notepad as well?
Yes.
Okay, that's fine. So before I configure these things, I just very quickly I just go through. We are using Cisco 8211 router, and as I said, this is the IP that we configured, but I gave it like 1.100. Okay, so very quickly let's change this one because we want to sync it with our configuration. We go into interface fast Ethernet 0/0. First, I will show you what IP I was configured before. Show IP interface brief. As you can see, it was given 1.100, but as per my instruction, it should be 1.1. So I'm going to just change this IP 0/0 and IP address is 1.1. And that's it. If I do show IP interface brief, as you can see now it is synced with this one. So this is the 1.1 I have configured as per my notepad. After that, I need to configure the DHCP pool. Of course, this my voice over IP device will have kind of IP. This is just like a, your computer. It is going to get some kind of IP. From where it will get? From this CUCM. So this is how I'm defining a pool network, which is from 1.0, the default router, which is the default gateway. And this is the new thing for you, option 150. And if you remember in DHCP, we talk about options. And this is how where we're going to use these options. This option 150 basically will tell my voice over IP phone that whatever the information, the IP, the configuration files, the ringtone files, these all you're going to access from me because I have given this 1.1, which is the same router. Okay, so very quickly, I will share this file as well with you. So from your end, you can do the same configuration. So you need to go into global configuration mode and click on the paste. After copying this information, just click on the paste. So we have enabled a DHCP pool or DHCP server for this range 192.168.1.0. After this is more specific to voice over IP configuration. So what is it saying? It's saying that enable the telephony services on this router. Telephony services will be enabled on the router. How many maximum phones you want to use? Let's say I want to use 5. Then maximum DN. Okay, these are basically the number of lines. How many lines you want? Which I said 5. Then it is saying IP source address 192.168.1 on the port 2000. As I mentioned, this is used for SCCP phone, skinny client protocol. So this is a source you're gonna get everything from. And these are some other auto assign 4 to 5 and 1 to 6. I don't just want to go in detail. That's it. This is very little configuration, as you can see. Then you can move along with this same concept. Okay, just copy paste into your router and things will be work. So let's very quickly. So as you can see, the DHCP address conflict because 1.1 I have assigned to this machine and it is giving. So what you can do, you can type IP DHCP exclude address 192.168.1.1. So because this was giving me the confliction. So I just removed that one. So let's very quickly configure this part as well for the telephony. If it will give me some error, we can manually type as well. Just paste and hit enter. And then just copy this portion. Yep, so far so good. And by the way, these auto assign has to do when automatically, it will tag my IP, these IP telephones. Okay, so this has to do with the tagging. It automatically it will do the tagging. So if you are more interested and keen to know a lot in detail about voice over IP, as I said earlier, that you need to go through these all commands one by one, and you can dig deep. What is this? And sorry. Then you can do auto assign 1 to 5. Okay, so we have configured until this part. And now this is the final piece. We have to mention this phone has DN1 line, and I want to give the number. And we know that every phone has specific number we need to dial on. So this is the information that we are going to put here. So under configure terminal, phone information I'm going to give, just a minute, phone minus DN1, and then number is 54,000. So I'm going to assign the number to this phone is 54,000. Okay, my dialing number basically, and hit enter. Now at this moment, this IP phone should be configured with this 54,000, and you can see, yep, if you have a very good visuals, you can see 54,000 is mentioned here. Okay, so since we are here, let's very quickly add another phone, because we want to check the connectivity as well. So come here, add another phone, this phone. Connect this phone with a switch. And let's make this one 54001. Means I want to assign this dialing number to this phone. So first thing first, we know that we have to assign the voice VLAN to this IP telephone. So we need to go into the switch, go to configure terminal mode, and we know that this phone is connected at fast Ethernet 0/3 port. Go into that and then make switch port voice VLAN 1 and no shut. That's it. Save the configuration and close. Now we need to go again into this router or the CUCM, and then just you need to add this command only. But this time it will be dialing number 2 and the number will be 54001. So let's do it very quickly. Go to global configuration mode. Phone minus DN is 2. This is my second phone. And I want to assign the number 54001. And that's it. Now this phone will be registered to this phone. And we miss one thing, that is the power. So if it is down, you can come here, just plug in on, just plug that power and click on the GUI. So it is going into configuring IP, and maybe it will start because it is going through some spanning tree. As you can see, still the link is in a orange. So it is just like initializing right now. So let's give it a moment. Okay, so the link is up. If you want to confirm, you can check whether it is registered or no. So again, you can type again. Yeah. See, it took time. It took a little bit time to make the configuration. Now, as you can see, this is now configured with 54001. Okay, so for the connectivity, I just can quickly dial to 54,000 from here, 554, then 1000, and hit enter. So as you can see, it is ringing, and you can go here and you can see 54,000 is ringing currently, and you just click on this one. So it is connected. Okay, so I'm just giving you a demo to make sure that you know this is the strength of this packet tracer, by the way. If you have any confusion, please ask. I will share this file as well. And then you can go through the same way, same process I went through just to get your hands on for the voice over IP.
Yeah, so think about the tickets that you may come across or interview questions. So just go over your, test out modules, and then think about certain things like if somebody called that I plug in the phone, but I'm not getting an IP address. So you should understand what's going on. I plug into we are getting an IP address, but certain things are not working. So you should be able to understand which devices or which management pieces do I need to know to be able to manage this. And not at this level, like we talk about, you just need to understand at understanding level. You really don't need to go into and start doing things, because this is still a Network Plus Pro. So if you still feel like, man, that's too much learning switches and routing, and now on top of this, I got to learn voice at this level. So this shouldn't be your priority, I would say, right? You should understand it, how it works, but don't make this a pretty big priority that you have to now learn this at very deep level. Okay.
Yeah, this is just like add-ons, you know. If you will add a value to your CV or something, it will be more appreciated. You know, somebody will be considered, like if one is having no knowledge, but someone having routing and voice over IP. So this is how, you know, it works. So at least you must have an idea how voice over IP phone works,
Yeah,
and
like
what are the.
let's say hopefully, or maybe luckily, you get an opportunity right now and somebody call you, hey, I'm going to teach you to become a network engineer. After doing this, I think you're going to be more comfortable to even learn this, because if they say we're using Cisco voice, this is our product, this is what we use. After going through just this, or maybe doing a practice packet tracer labs, I think you're going to be very comfortable. I think at that level. But after CCNA courses, I think if somebody then call you, hey, we are using Cisco, products, and you maybe say, oh yeah, I think I can configure that. I mean, I am at that level that I can understand this, what exactly goes on. So two different feelings at this point. Okay.
Yeah. So let's move to the another slide, which is talking about the Nas and Sand. And basically these has to do with the storage, because since in your test out lab, we have these sections. So that's why we added. And NAS, basically, you know, this is for your small, like in a home, if you want to connect multiple like these devices, this is known as NAS, which comes with a redundant disk. Okay, and you want to store your information like movies or whatever the data you have. You don't want to keep it on your laptop, but in some another device, so everybody can access. Okay, so this is where we use NAS, which is network attached storage. And basically it is connected with something like, you know, if we have a router, and then this router is connected with this thing, and then you have, you know, computers, your laptops, your devices, your phones, whatever the data you want to access, you can access through this network attached storage. So, but the I mentioned here the drawback is that, you know, if either this device is fail or this device is this connection is fail, nobody is gonna access this device. So this is the drawback of this thing. But in production environment, most of the time, that storage concept that is being used or the devices are used are SAN, storage area network. And how this looks like, it will be like this. These are normal switches. Okay, these are the servers. And then these are these SAN devices. Okay, then we have multiple redundancy to reach those SAN devices. Even in your data center, if we talk about, they are using SAN kind of topology. If you want to upgrade, you can add more devices, hard disk on that. Either it is SSD or your normal SCSI. Okay. And even this switch is down, still we have kind of redundancy. Danish, if you want to explain more on that, if you have.
Yeah, I mean, this is like, think about this. This is probably the most important thing in any company, to be honest. If you go to a company right now and you say that, you know what, I am going to be the network engineer or even a sysadmin, and I need to manage this whole company, right? So if you think about it, actually, when we talk about, you know, these different type of devices and everything, it has to have some type of storage out there. And most of the companies are going to be using this type of technologies where they can centrally manage all of their you know, their storage. So if that fails, if a connection fails to that storage, your whole network is down. Because the current method these days is what? Do you guys know? Do we use a lot of physical servers these days or virtual servers? What do you guys think?
Virtual.
Virtual. So that virtual servers also needs a lot of, like, you know, it has to connect to a lot of like, you know, storage devices. Even if it's, let's say, normal VMs like domain controllers, a lot of different type of management servers. You can't just have a local storage running, right? Imagine for each server, if you had to have a local storage, what would happen then? You would go to each local server, local storage, and try to manage it. So if it runs out of space, you will be doing a lot of manual work. So again, we're back to the management. So when you want to get into this type of jobs, there's no way you would be able to proceed, because your backend, the bone of your network, like where things are running from, is, we know that as network, that's a connectivity part of it. But where's the data? Where are these things happening is the most critical part for any engineer level person to understand. So number one, I think from your test out, try to understand the difference between NAS, SAN, different type of storages that are available out there. And even these days, there are cloud capabilities as well. So I'm going to give you some visual presentation now, just to show you how powerful these things are. So then when you go into a network now as an engineer, you're not going to be scared of these things. So two things I want you to know. Why did we in the beginning talked about the physical side of things and a different type of connections and different type of cables? And this is where it plays a big role. When you go to a data center, most of the things that you're going to see are this type of devices, and it uses that fiber connection, different type of serial cables. You got to understand that from your test out. So I want you to really go back and maybe try to revise that if you feel like this is something you're going to lack in your company. So that is the key right here. Okay, so I'm going to show you a practical example. I'm going to share my screen with you all, and let me see if I can.
Shall I stop sharing, Danish?
Yeah, go ahead.
Okay.
And let's see, I'm going to clear my, why is my draw? Okay, hold on. Okay, can you all see my screen?
Yes.
Yes.
Okay. So look, when we go to we talked about a data center over here. So you go to a company, this is the company again. And now we're talking about a pretty much like the first things in the company, right? So we're talking about hardware level at this point. Okay. I want you guys to think about it. If I have to run, let's say 200 virtual machines, and it has to do different things. Some has to store files, some has to provide some services, things like that. What do you guys think? What should I buy over here? This is my data center. I want you to give me some ideas. What should I buy?
If you want to do what, sorry?
Anyone?
What was the, can you hear me?
Yes.
What was your question?
My question is that if I have to, let's say I have a lot of clients over here, I have a lot of staff members. These are, let's say, about 600 staff members. They have to save their files. They have to do a lot of things. Then there are some external people that need to send files to my company. So there's again files, storage, and everything that needs to be done. And there are some Cisco devices. There are some services that needs to run inside this company. So what should I buy? Like from a hardware level, can I just go and buy every single server, just start buying like Dell hardware for each and every server, or should I go for some different solution?
I think you should go for mini solution. I mean, you will have to buy those bigger storage.
Okay, good job. So bigger storage means that I don't need to buy for each and every service. I don't need to buy each and every single physical server over here, right?
Mm-hmm.
So it's kind of like the same concept for virtualization, but I'm not talking about virtualization at this point. I'm just talking about what can I do to not go for many different type of physical devices, and I want to manage things from one single point. Do you guys know any solutions?
You have to share a big size of storage.
Exactly. So for big size of storage, is what will happen then? I mean, yeah, I can go and let's say get a big storage server from somebody, but I still have to manage it, right?
Mm-hmm.
Yes.
Okay, good. So now what happened right now, currently, if you go to a company, again, this is something that you will not need to learn right now, but know the names, and maybe you can do some research to add it on your resume if you want. So UCS, okay, it's a Cisco product, I would say. So let's say this is a data center. In data center, I went ahead and I called Cisco that I need UCS from you guys. And this is kind of like a server, basically, it's not a server, it's like a chassis. And inside this, it has multiple servers in there. Why am I drawing on this here like this? So it has multiple servers. So it's like a one big device. What it comes with is a mini servers that you can slide it in that chassis. Now I'm using all these normal terms. These are not technical terms, but I'm just using slide it in, slide it out. So this could be one server right here, like a physical server, but back of that chassis, you have different type of power connected. So power 1, power 2, power 3, power 4. So this is connected to, like, let's say power, right? Power management. Then you have these servers. So now here's the thing. This server is a real server. It's like a normal server. It saved me from going out there and buying multiple big servers and rack it up, right? Now I bought this one big chassis that is built to take something like smaller size servers, and you just plug it in there. Like you just hold, like, the whole device, you just plug it in to that main chassis. Am I making sense so far?
Yes.
Okay. So you got server 1, server 2, server 3, server 4, server 5. So yes, you could have a local storage on these servers, but at some point you're just going to run out of that local storage. So that's still not a good solution. But for managing these servers, that's what we use these days, UCS or anything like this. So you as a network engineer or a sysadmin needs to have some type of networking going on from your switches or routers, whatever it is. I'm not going to talk about networking here. You just got that done. And this UCS, you have network connection going on through some IP address, right? And from a web or from like some kind of software, you manage what? You manage this whole chassis, right? So it
Yeah.
has all the servers connected to from this portal. So you can go to server 1, and in this server, then you can install what? These days, what is the hot solution? Virtualization.
Virtualization.
Exactly. So we could have a ESXi here, 1, 2, 3, 4, 5, 6. With this having 300 GB RAM, 300 GB RAM, 300 GB RAM, 300 GB RAM, how much RAM do we have, right? So it connects everything. Then you have to use some other solutions to manage this whole virtualization, but that's coming. That's next. I'm going to talk about later on. But for now, I want you to focus on this UCS part. Okay. So when we talk about storage, then we're not relying on even this local storage, because that's still not enough for companies. They go for what? They go for another big server. And that could be another solution. So some of the solutions are from Cisco, from Nimble. There's like different companies, right? So one solution that I'm going to show you right now is called Nimble. Okay, I'm just going to give you an example of how a UCS is connected to what? A storage system that is way bigger than what this is going to hold. So I'm not going to use a local storage on this server. I'm just going to use the connection and management piece. So then I can use the storage this UCS is connected to this Nimble. And what's going to happen? These servers are going to use what storage from where? Local or from here?
From there.
From there. There you go.
Nimble.
Exactly. So let's go to Nimble now. Let me show you. First, let's go to UCS.
We can't. Oh yeah, we can.
All right. So what did I talk before? What is the chassis here? This is the chassis right here, right? Do you guys see it?
Yeah.
Yep.
This is what I talked about, which has one server, 2, 3, 4, 5, 6. Okay. I can double click on it and go into it, but that's going to get a little bigger. So right now, this is then connected through some of these fiber interconnect, like these are little switches that are like special switches, right? So this may connect back to where? That Nimble, like this may go back to some kind of storage that what Kamran was talking about, SAN or some type of storages, right?
Okay.
So this server, then it's like configuration is done inside this server to use this type of solution. So you may have one SAN or you may have two like that. So if one goes down, what will happen?
The other one is redundancy.
Redundancy. If I click, let's say, let's go ahead and clear all of this. And let's click on servers. This is what I'm talking about. Inside that chassis, how many servers do we have?
6.
How many cores do we have per server?
1.
Wait.
Oh no, 20 cores. Sorry.
I thought you said. Oh, okay. Cores.
One
Yeah.
server comes, like I said, this, when we talk about that chassis, right? This chassis, this little piece that you see on the top right here, 1, 2, 3, 4, 5, 6, right? Each is a separate server, but this chassis is managing. So what the system that you guys are seeing, look on the top, what am I logged into? Cisco Unified Computing System Manager, right? So that chassis is what I am on right now. I am not on the server yet. If I want to go into a specific server inside the chassis, what would I do? I will click on server and I'm going to go in straight into that server. And on that server, I can install ESXi. And then of course that becomes a virtualization skills there. But you see, I'm controlling my whole network from where? From this one chassis connected to a storage, right?
Mm-hmm.
So now give me a question, give me an answer. So this is kind of like okay, this is the chassis part of it. This is the management part of it. This is my hardware in this one big block, right? I'm managing it. So then I need another big product from different vendors. So I said I bought Nimble. So let's go to Nimble now. So I went to Nimble. Do you guys see that now?
Yes.
Okay. So look at this. Look at the amount of storage on that, 22 TB on top.
Mm-hmm.
And that's just one. So How does it look on the front end? You go to a data center. How does it look? It's going to look like this. The server physically is going to have HDD, so many hard drives connected to it, and it's going to blink with green, orange, or whatever. If it is having issues, it's going to have different lights. Okay. So here you see, if for example, this was to go down, like in that where is it connected to back to that chassis? This thing is pretty small, so let me see if I can make it. Do you guys see that FC1 and FC2?
Yes.
That's where it's going back and connected to that little switch that is connecting back to UCS. Does that make sense?
Yes.
Yes.
So from UCS, we are connecting a storage, which is so much that everything is running on here. All of your virtualization technology is actually running mainly in most of the companies are running on something like this. So give me an answer right here. If both of these devices were to go down, can I access my UCS? Let's say this is a storage device right now. It's at this point, it has nothing to do with UCS. It's just connected through this one connection, which is a switch right here. This switch that we talked about is right here. Let's go back to the main, this right here. So let's say it's connected to FC, this port 31. So this is the one, right? F fabric, right? So it's connected to, let's say, this port 31 right on the end. If both of my storage devices has to go down, can I still access UCS, which I am on right now?
Yes.
Yes. And why did you say yes?
Because the storage is within UCS. It's not the main component.
Perfect. The storage is not a part of UCS. It's just connected to it. So I'm just using networking to connect to my storages, right?
Mm-hmm.
So if my storages were to go down, and let's say every single virtual machines are using my storage. For example, in this UCS right now, we have servers. Under this server, we install ESXi. Under ESXi, we have domain controllers. Every virtual machine is running. And my storages went down. Can I access my, first of all, can I access the virtual machine from
Yes.
network?
Yes.
How?
Through this system.
So through this system, you say that I can access my virtual machines.
Yes.
And I say that the whole storage is down because the whole storage is connected back to where? Like when you install a virtual machine, you have to have some kind of storage, right?
Oh, so no, you wouldn't be able to go into your virtual
Exactly.
machines.
Your virtual machine are down at this point. If your storage system didn't work properly, if redundancy didn't work, what happened then? If both of these went down, both of FC1, FC2 went down, you can only get to UCS, but your domain controller, virtual machines, everything is down at this point. You see the importance of storage being connected to something like this?
Yes.
And the redundancy and how you need to understand all of these different type of connections. Because as a network engineer, you need to come over here and see why FC1 is down. So let me go back. Where is the source? So now let's not talk about just only these products. It could be any product. It will be similarly connected to anything like this. And you need to then troubleshoot that, right? So if I was to come back over here and I want to solve the solution, what would I do? I would go to the UCS and first I want to see what is the issue. Is this the issue on a server level inside UCS, or is the issue on the main UCS connecting these connections like FC1, FC2, like these little ports? So again, then of course we're getting into a little more details of troubleshooting storages, but that's not the part of this. Did you guys got the whole idea of how networks are connected these days in the market?
Yes.
Yes.
Okay. Now again, this is something that you may see in a company. And if you go to the company right now, they may be talking about upgrading this whole structure to something more advanced. Or not advanced, more modern.
Infrastructure as a service.
Yeah, so basically what I'm talking about here is that this UCS that you're seeing is very old. So there's two things. One, you can upgrade it to new versions. Maybe they will support it to, I don't know, however long they will support it. But Cisco now came with a new technology, which is called HyperFlex Connect. So if you look at it right here, it's almost the same thing that you guys are seeing over there, but in a little better way, right? You got data stores right here, and data stores can be connected where now? To cloud.
Oh, that's really cool.
Okay, 1 TB from the cloud now. You can run your virtual machines on the cloud. You can have a full system, the same thing that you saw over there. I can click on here and I can see the same thing going on. 4 nodes. We have 4 nodes over here, and all these nodes are just like what we saw in our UCS. So hypervisors are running on those nodes right now. These are the IP addresses, right? So it tells me that everything is running. All these disks are right here, and if it's something happens, I can clearly see what's going on with my disk, all that stuff.
Wait, can you hover over one of the disks, please, for 1 second? Okay.
It tells you like how much space is done.
Yeah,
It tells you the
that's cool.
type is SATA or different type of devices on the bottom.
And Danish, I have a question. And when we use Hyperflex, is it still SAN or it changed the name? Like it's cloud?
It's still SAN, but it's connected to the cloud, just like any other products out there. And it's not just SAN solution. It's like a mixture of. You can even use, like, for example, this Hyperflex is actually connected to a local connection, and then you can connect this data store is the main thing over here. You could either have it mounted to a local area, or you can have it mounted to a cloud, which Citrix Cloud is an example over here. Okay.
I'm sorry. Is Hyperflex considered a UCS?
No, it's like a better version of UCS.
Okay, so UCS is a specific product. It's not idea like virtualization.
Yeah, so
Okay.
UCS is a hardware product that gives you a great power. Like, so think about UCS, one system with a lot of power, a lot of RAM, a lot of memory, but then
Got it.
inside that system, let's just open it right now.
I was just not sure if like this whole idea has like a name.
Yeah, I know it's a little confusing, but let me see if I can open.
How old is UCS? Like how many?
Oh, it's so many. I mean, I don't remember that years, but it's a pretty old technology. But it's not old. It's more of like they keep updating, just like any other Cisco products. Like ASA is years of old, but they update it like with new versions and new product, new hardware. So the UCS on the front look like this. This is an exact image of a UCS, by the way, and it gave this really nice way of where are things connected. So UCS is like this. Back in the data center, this whole device is like a one big chassis right now.
Right.
You see it? And this right here, what you see, give me 1 second. Where's my drawing? This is server 1. You guys saw that, right? This is
Yes.
server 2. 1, 2. So I can have another server. I can go to eBay right now and I can buy a server and I can just plug it into this UCS. Is it making more sense now?
Yes.
Got it.
I can buy another one here. These are running. So under this server, this is like a power here. This is RAM, memory, cores, RAM, memory, cores separately. So I can then install what on this?
Servers, or sorry, virtualization.
Virtualization, ESXi host. So I will install what? Host. And then how would I manage all these hosts?
Using UCS.
Nope. No, not managing. Like, how would I then internally manage these hosts? I'm going into virtualization now, just for a second.
Oh, from ESXi?
The
What?
vCenter.
vCenter. So ESXi will let me log into this server only with an IP address. So that's okay. That's a solution, but that's when vCenter is not working.
Okay, got it.
A vCenter is also a VM somewhere, and you go to the IP address, and then from that IP address, you manage all of these servers from one single console.
Okay.
Internally, like the VMs. And once Kamran talk about virtualization. We're going to come back to this again. I'm going to show you the same image, and then I'm going to show you virtualization in a vCenter, how this is configured inside the vCenter, all these servers. Okay, so let Kamran take over now.
That is very great demonstration, Danish, and you explained a lot in detail. Thank you so
Thank
much. Can you see?
Yes.
Okay, and this my mouse pointer and this.
No, we don't.
Okay, okay. So let me.
From now on, when you guys see a PowerPoint image like this, I hope you guys are not confused. Then it should be pretty clear now.
So only drawback in the SAN is, as Danish was discussing about those SAN devices, actually it's expensive. It's very expensive. And by the way, these things they are using, these are fiber channels. Why? Because we need more speed. As you can see, it can start from 2 all the way up to 128 gigabits per second.
Yeah, we just implemented a solution for a company, and we're talking about, if you want to do the whole thing from scratch, we're talking about more than $128,000 just in a normal data centers.
So let's start with the virtualization. And in the quiz, I asked, and I also explained a little bit that as well, that let's suppose we have one device. That organization, in early days, what used to happen in old days, we have multiple servers which is running multiple services. Like this is domain controller. This is just like FTP server. We were talking about the storage. Then this is like SQL server. You can notice how much money your owner is gonna invest on these devices. Then behind the scene, there is infrastructure as well, and there are so many things. So the virtualization then jumped on and gave us, solution about that. So now what we do, we have the same fashion, we have single device. And in the same device, we will deploy kind of software that will do the image or virtualization for the rest of the servers that I mentioned previously. So you can deploy all your these services on the same box. So we are not only saving the money, but usually these devices are very high-end devices. Like they have a very powerful CPU process, they have a very good RAM and the storage. Okay, so running only one service is like good for nothing. So why not we make the virtualization and deploy the rest of the services on the same box? Okay, so we are saving the money as well as we are using the resources of this single device as well. So as for from the diagram, as you can see, this is how it looks like. We have one host operating system. Of course, we need one host operating system that will run hypervisor. And on top of that, we will have operating system 1, operating system 3, 2, 4, which will be running multiple services like FTP service. This is running like, let's say, kind of NAT services. This is running like Dhcp services and like SQL and so on. Okay. So from the definition, it is written in computing, virtualization is the act of creating virtual version of something, including virtual computer, hardware, platform, storage devices, computer network resources. Using one physical device, install multiple operating system as a parallel. So these are the multiple as a parallel running. If you can run 5 operating systems in one computer, you are going to save money that you would spend on the purchase on the other physical resources. So you can spend that amount to purchasing other devices as well. And the examples of hypervisors, as we know, VMware. Then we have VirtualBox. Then VMware, that is belong to the same, but with ESXi version. And for the Microsoft specifically is Hyper-V. Okay, any question, or if Danish also can add something on it?
Yeah, so I think I will take over and just give you some examples of this, because we were on that. When we talk about a hypervisor, we already talked about the UCS part of it, right? That was what we were covering. And then how do we really work on the management piece? So let me start the process here. Okay. So let's share the screen again. And can you guys see my screen?
Yes.
Yes.
Okay. So Kamran just mentioned, we will not just go for a one small device or maybe a servers that are, that are kind of like, you will not be going for a lot of different physical devices. So that's why we already cleared the concept of UCS, and you guys know that. So if I buy something big like this, all I gotta do is to buy more servers from eBay, and all I gotta, oh, not eBay, I mean from Cisco. eBay is me, okay? Somebody like, what? You get, okay, so this from like any professional people will just contact the vendor. You always have vendors work with you, like Cisco vendors and different type of vendors. So I bought this 1, 2, 3, 4, 5. Let's say I need more. I'm running out of space, or I need more RAM or things like that. I mean, I'm gonna buy another one, right? So now you must be wondering, what kind of solutions can we put on this? Now, of course, this is where your company will be doing a lot of homework, whether they want to use a hypervisor solution on a hardware level, or they want to go for like, type 2 type of solutions, like, Hyper-V type of, like you put a Windows Server 2019 and then you put Hyper-V on it, which is rare, but a lot of people use VMware. That's why we want to go VMware, because that's is more well known in this area. So now, if you talk about this, you must be thinking, then when we install everything on this, so of course you either want to do it on a network level, USB level, whatever you choose, you will install that. We're not getting into UCS learning. Let's say I configure this. I went in there, I put the ESXi on it. Then what can I do? How can I access ESXi on this server? You see, the power of UCS is that I'm already in this system. All I got to do is right click, and what? I can get into the KVM of that ESXi, right? So if I click on the KVM, what happens? I'm going to be connected to this ESXi directly. So let's just try that and see what happens. So there you go. That's an IP address. And I'm sure at this point, you guys have seen some help desk videos from my end. And I think you guys, at this point, when you were learning help desk, I think your level of learning stopped over here. We never went into vCenters or anything like that, right?
I think so, yeah.
So most of you know at this level information, where you put an ESXi and you get into that IP address, and then you put virtual machines on it. And I do remember, Haifa, for your training, you have installed virtual machines on ESXi. You haven't done anything on vCenter, right?
Correct.
So now imagine if I had 6 of these ESXi's running, all of them have what? Single IP addresses. Not a good way to manage all of these 6 machines, right? 6 servers, right? So what's the solution to manage all of these 6 hardware level ESXIs right now? ESXIs are installed on this. I can get to it by IP address, but I think we're still cleared it before. What can I do over here? What can I run?
vCenter.
vCenter. So for people knowledge, we're talking about vCenter because that's a VMware solution. It could be any other solutions, but you need a single management, single point where you can access all these server from single address. Okay. So for that to happen, you need to learn what? This is a learning tip right here. What do you need to learn?
To access vCenter?
Yes, to learn about vCenter, ESXIs, what do you need to learn?
Virtualization.
And virtualization of VMware, right?
Oh, okay.
Okay, so now for our members, you, specifically you guys, and anyone in future, we also have, remember, also have a full ESXi vCenter labs in your practice lab. I just jumped into the vCenter right now.
Okay.
I'm not sure if you knew this. We do have that, okay? So all I had to do is to turn on the vCenter lab, and now I am actually in the vCenter. So just assume we are connected to what? That UCS through this single IP address. After when I configured my VMware, after I learned this skill, I know what I'm talking about now. I am talking about vCenter. I connected my vCenter to those ESXIs, and now where can I find those ESXIs here? What do we call ESXIs in terms of connections to vCenters or anything like that? What are these things? What are these servers called?
Storage? Hosts and clusters?
Host, yes. It's actually in most of these places, they're going to call it hosts, okay?
Okay.
So if you look at it, this is our UCS right here. This right here, UCS is in London. And in London, how many hosts do we have? One. So if we go back to our example, we're only connected to this one host right here. If I had configured all of these 6, then what would I see here? How many hosts would I see over here? 6 hosts, right? Exactly. So now from one single point, I can access all of these hosts. And then this is where the beauty of virtualization kicks in, because then virtualization takes over. Let's say if this machine was to go down, or let's say this host went down, what can happen to this VM?
Could you repeat the question then?
If this host went down, let's say this physical server here, this one went down, and you have configured the virtualization the way people would configure, the power of virtualization play a big role over here. Let's say this physical server, number 1, went down. This one went down.
You can replace it. And let's say you can't fix it. You can replace it and then just
But I'm sleeping.
link it to.
I'm sleeping right now. This is 3 a.m. This went down. What will happen to this VM?
It will still run.
How?
Because it's only.
If I have 6 hosts right here, assume we have 6 hosts right here. And this.
Oh, then redundancy, like one of the other 5 are going to kick in. Or take its place.
So if you, now I'm doing a learning tip right here. If I would have configured my VMware or any virtualization, these are like the features that I'm talking about. Virtualization, we're talking about virtualization over here, right? So I'm explaining the power of virtualization over here. If that was to go down, then what will happen? This VM is going to move to the servers that are actually running out from here. It's going to just move the management piece to those servers, because the storage is running from somewhere else. So we don't care about this server going down right now at this point, because the storage of this is not even here, right? It's the storage that we talked about before, right? So these other servers are managing these VMs. So I don't care about, because this is the big thing right here. If it was to run from this server locally, if this was to go down, then we're done right here. Right? But here, because the storage is somewhere else, then because of my knowledge of VMware, I have set it up the way if my host A go down and any virtual machines in host A automatically move it to the second one. And all I have to do is wake up in the morning and like, oh, we got a hardware down. Let me fix it. And I fixed it. I came back. I turned it on again. Everything back to that server. Everything good to go. You see how easy it is these days?
Mhm.
If it was a physical devices, trust me, you would not want to become a network engineer anymore.
Mhm.
Because you had to go there and you have to configure everything. You have to recover that hardware. You have to recover the hard drives, everything. You have to recover it manually. Here, virtualization made our job extremely easy. And on top of this now, we are connecting to cloud. So if this was to go down, the whole servers were to go down, then some companies have now backups in the cloud. You could bring everything down from the cloud. So I'm just kind of moving you guys to what we are using currently these days. So this is the vCenter right here. Now, again, a tip for you. If you guys are good at basics, I want you to go to the VMware. I want you to go to these labs. I want you to learn what is a vCenter. I want you to learn about ESXi's. I want you to learn about these features, what I'm talking about. If one goes down, how can this move? I want to challenge you or to leave you this homework to you guys. What am I talking about over here? I want you to find out these features. So when a VM goes down, how does it even move to a second server? I want you to do that homework. Then you will understand what I'm talking about, okay?
Got it.
So far, virtualization. Now you have seen something visually from all the way from UCS to all the way to what's running in the UCS, from all the way to what's managing UCS is like a product, a VMware. Is everything clear so far?
Yes.
What do you guys think?
I have a question. I understand UCS. I understand this SAN.
Huh?
Now I want to know where is vCenter? Is it because I know that ESS
Good
has.
question. So vCenter could be a VM in any of these ESXi's.
Okay.
It's
so,
just the management piece.
so
to connect
once sorry.
Yeah.
So once ever gonna manage all the rest. Is that what you say?
So that VM, it could be on an ESXi, like let's say A. And if this goes down, I could put the VM on B and I have vCenter running again.
Okay, because we only use an IP address, right?
Yeah, so for
Okay.
vCenter to be configured, now this is a VMware knowledge. For vCenter to be configured, you need to have a domain controller running, you have to have a DNS running, because then you need to control everything from that. So let's say if your UCS is down and you have some connectivity issues, then of course your domain controllers are down too, right?
Mm-hmm.
Then of course your vCenter will work or not. It won't work.
No.
Then what happened in this scenario when you can't access a vCenter? Let's say I want to get into this vCenter, this one. I want to get into that, but that you see, it has a fully qualified domain name, but my domain controller is down. How can I then get back to my vCenter?
You have to create another domain? No.
No. So if my domain controller is down, which is also a VM in one of these ESXi's, it's down right now. And my vCenter is dependent on that domain controller, but I cannot get to the vCenter now. What is my other solution? Where would I go? Take yourself back, a step back from this. Where is my hardware running? How can I get to the ESXi's now?
To the you go to the physical hardware.
Oh, good job right there. So you have to go where? The UCS. And where is the ESXi running? Directly on top of this server, right?
Mm-hmm.
So what do? We KVM into that.
Mm-hmm.
Yeah.
And then I find the IP address. Then what do? I can go to the web browser and directly type the
Type in the IP
address of the ESXi. So in that ESXi, what is running? The domain controller. So I will just restart the domain controller. If the vCenter is having an issue, I'll just restart the vCenter.
Okay.
And then I'm back.
Got it.
That actually happened recently to one of the clients that I was working on. they lost the connectivity on UCS, and somehow when you lost the connectivity to UCS, and maybe it has a storage issue, a storage could not connect. So what happened? Every single thing is connected to storage over here. So this is why I talked, Haifa, if you remember, I asked you a question. If your storage is totally down, none of these VMs are going to work, right?
Correct.
So if none of your VMs are going to work, then what's happened? Your domain controllers are down too, right?
Mhm.
Yes.
So when your domain controller is down, then can you use vCenter?
No.
No. So when everything like that is down, where do you go back? You go back to the hardware level KVM type of solutions. This is your hardware then. Then you find it. If at this level everything is working fine, you get into a direct IP address of this ESXi. So if I want to get into this ESXi now, what do I need?
The IP address.
If I want to get into this ESXi, what do I need?
The IP?
The IP. I'm trying to find that, but maybe you might not have it. It just says localhost here. Network. Anyways, well, that's something VMware. We don't want to go into that. But you're going to need an IP address of this. So I can go back to my what? To my KVM UCS and find that IP address, just like this. Let's say I don't have access to this right now. Either you remembered it, or either you need to find it. And you physically, if you need to find it, you need to go to the product, whatever you're using, and KVM into it and find the IP address. Type the IP address into the browser and turn on what devices you're having issues, because now you have a domain controller issues. We're moving above virtualization, but still, I wasn't virtualization. You need to understand all these different skills to get into ESXi's. This is what we're talking about, right?
Question. I don't know if
so
this.
far, everything clear? Yes.
I don't know if this happens, but what if both the UCS is down and your domain controller?
If UCS is down, totally down, you mean like you cannot get access to it?
Yeah, you can't get access to either of them.
Is that your question?
Yeah, you can't hear me, Donna?
Okay, so if your UCS is totally down, this means your management is down, right? So if it's totally down, so what's down? Let's say this is down. Like I'm just talking about no lights here, no lights here, nothing. The whole thing is down. Power failure over here. This is the failure. This is where it says fail.
Then you would troubleshoot the hardware like aspect. Oh, or your.
Yes, there's no other way.
Okay.
Right? You have
Okay.
to go into the business physically, check the power. So sometimes it could be shut down or it could have some kind of issue. So you will unplug the 4 cable that is connected to the UCS power, plug it back in, everything should come back up.
Okay, makes sense.
And this will come up, this will come up, this will come up. Your UCS is up. Then you will need to find out if your ESXi's are working fine. Then you need to find out if your virtual machines are actually fine, because virtual machines could be shut down in an improper way and everything will be like blue screen of death and everything like that. You have to go inside the ESXi's and manually start everything.
Okay.
If your vCenter is down, if your vCenter is up and everything, let's say your domain controllers are up and running, then you don't need to go to each and every ESXi. You need to go do a vCenter and just here. Here, you just need to go here and then get into a VMs just directly from these ESXi's. Like for example, what I am on right now, right? So I can come over here and I can just say, okay, this is the London, this is the host. And then in host, we have virtual machines and I can restart all these machines again one by one. So hopefully the virtualization, at this point, knowledge is okay. In future, I want you guys to do these labs so then you become more of like a person to go to the interview and say, I know about vCenter, I know about vMotion, I know about these different features that it comes with. I know about virtualization as an administrator level, not a help desk level, okay? And that's it from virtualization. Tamara, you want to take over?
Okay, sure, Daniel. Thank you so much. Okay, so let's move ahead and talk about what is cloud computing. So the cloud computing is the on-demand availability of computer systems resources, especially data storage and computer power, without direct active management by the user. Large clouds often have functions distributed over multiple locations, each location being a data center. So we discussed earlier about the cloud computing as well. Like, the problem is in the company, let's suppose I own a company and it has, let's say, like 8 to 10 servers required. And I want to access these servers and, for the management purpose or for my own purpose. Okay, so we know that we are going to spend a lot of money for that. And let's say if I give you a practical example of that, for example, if I want to open some services just for the temporary purposes. Okay, I know that my business after some time will be down and I don't want it running all the time. So I just want it for a temporary purpose. So do you think I will invest a lot of money just for a temporary solution? No. Then what is the solution, and the remedy is the cloud computing or the cloud services. The cloud, I can go into the cloud and I can purchase whatever the devices or the services the clouds are providing. So this is like a very cheap solution. Okay, and you are going to save a lot of money when using cloud services. So the other benefits and the features included in cloud computing is scalability. As it is mentioned, scalability is the ability of the system to accommodate larger loads just by adding resources, either making hardware or whatever these things are. Means if this is a service, you want to add more services on top of that, you can add more resources. You can add further servers on that. This is called scalability. Then we have elasticity. Elasticity is something different than this scalability. Elasticity has to do with the single resource. Means I can, for example, this is a server. I can increase hard disk drive. I can remove the hard disk drive from the single resource. That has to do with the elasticity. Then other benefits like availability is simply, is the source there or no? The server that I am accessing is available there or no all the time. Then reliability, how reliable or what is the performance of that server is. So these are the features that comes in a cloud computing. Then we have multiple types of cloud. Let's say this is a public cloud. This is by default. And examples are mentioned like Microsoft Azure, AWS, IBM, or Alibaba. If we want to take the services from them directly, those comes under public cloud. But let's say I do not want to take the services. I will take service from them, but I will keep them as a private. So that assets will be belong to me. Like if give you example, like HP has its own data center. In case if the JSS want, they can also have their own data center. So that comes under the private cloud. Then the third one is hybrid, which is the best of both worlds. Means you can take some portions from the public cloud and then plus from the private cloud. So adding these two makes hybrid cloud. So these are the cloud types basically. Then we have a cloud service model. And in the quiz I asked and you gave a very good answer to that. We have infrastructure as security service, then platform as service, software as service. And what are those things? Infrastructure as the name implies, infrastructure. It means we are going to deploy kind of infrastructure on top of that, like hardware resources, networking devices, something like that. It belongs to the infrastructure as services. So infrastructure as service is a type of cloud computing service that offers essential compute, storage, networking resources on demand. And the example is same like AWS, Azure, Google, IBM. They are providing these IaaS platforms. Then we have platform as service. If I give you example, just for example, if JSS is having kind of test out labs, okay, they can put on platform of the cloud services. So you can access those from the cloud services. So platform as service is a cloud computing model where third party, because JS is a third party. Third party provider delivers hardware and software tools user over the internet. Then we have software as a services, and the examples are like Dropbox, Facebook, Salesforce, and Office 35. We are using on day-to-day basis. So those are examples of software as a services. Any confusion until here? If you can ask the question.
So far, so good.
Okay, that's fine. Then this is cloud types visual breakdown. What I talked in the previous slide, you can see this is the on-premises, and we know what is on-premises. When you are owning everything, this belongs to you. Everything like from networking, storage, services, virtualization, operating system, all the way up to the application, this is your responsibility, and this is on your on-premises. But when we talk about infrastructure as services, the things that you are going to manage are operating system, middleware, runtime, data, and applications only. And as you can see, the infrastructure has already been provided by the, let's suppose AWS or Amazon or Google, IBM. They have already given us like networking, storage, services, and virtualization. Then under platform as services, very few things we need to manage because we are running just application on top of that. The rest of the things like after virtualization, even they have given us operating system, then runtime, middleware, everything. This is the responsibility of your AWS or IBM, whatever. Okay, so you will be only managing these two things as per your need. And the last is software as services. And we discussed like Facebook, Office 365, something like that. As you can see, they are managing all the things, all the way from networking to application. Okay, so they are responsible for that. We are just using their services or application. Okay, so in this session, I'm gonna give you a demo on AWS particularly. So that's why I put these things related to the AWS. And if I'm talking about the region, maybe if you will hit IBM Cloud, Alibaba Cloud, they will be talking about different things in the region. So these are more specific to the AWS. And a region is what is just isolated and physically separate geographical location. That's it. For example, it could be, if we talk about United States, it could be East, it could be West, something like that. Then we have VPCs. VPCs is nothing, just you can consider it like a container on which you will deploy your resources. And what resources are like your routers, switches, IPv6 addresses, subnetting, and everything. As you can see, Amazon VPC is a service that lets you launch AWS resources in a logically isolated virtual network that you define. you can use IPv4, IPv6, most resources in your VPC cloud. So this is basically going to isolate your network. So you can have multiple VPCs. Like this is VPC1 and this VPC2. Then you can deploy other resources in that. If you want to make this communication, they can do if you have deployed some kind of routing here. So the concept and idea is very similar what we have been doing. Then we have this availability zones and EC2. So basically, when we have the one main region, in main region, under main region, we have one, let's say one VPC. And then VPC could have a different availability zone. And these availability zones, like we have public zone or private zone. Okay, if I show you the definition, like availability zone are isolated location within the data center regions from which public cloud service originate and operate. Regions are geographic location in which public and public cloud service providers data center resides. When I will show you in the next slide, you will get the clear picture of it. Then we have EC2. This is known as elastic compute. It is nothing, just like a virtual device that is on top of that. You can run some services like Linux. You can deploy servers like Windows servers, Mac, something like that. So these terms are very specific to AWS. So what I said earlier, as you can see here, we have the region, and then we have VPCs, one main VPC. Then these are the availability zone. Under what zones these things are available, like this EC2 instance is available in this zone, and this one is on this zone. Then we have public subnets and private subnets. If you remember, we talked about the public IP or private IPs. The private IP is gonna locally communicate with each other. If we have multiple instances here, EC2 instances here, they are gonna communicate with each other. Okay, but this is public subnet. They are not going to communicate unless until we have some kind of router device inside it, which is having the information of this subnet as well as this subnet. So similarly, if these two zones want to communicate to the internet, they need to go through router, and then we have this default gateway. Okay, so this is same concept that we are doing, you know, in CCNA, but now they have taken these things one step further and put everything on a cloud. So that's, you know, I want to put emphasis here as well, that, you know, people, they're still confused why we need to learn the basics, routing, switching, subnets, these things, because the things have changed now. We are moving on to the cloud. But, you know, if you will go into the cloud, everything is very similar what we are doing locally. So Danish, if you also can add something on that what I said.
Yeah, I mean, if you look at it, most of the companies we are in right now, we call this term hybrid. And I'm sure one of you probably worked in this area, right? Where you have a local machines, local internet, local Active Directory, and then you have some type of solution from AWS or Azure, and then you connect to the cloud. So keep that in mind, that we're not totally 100% into cloud, and it's going to take a lot of time for some of the companies to move to 100% cloud. But even if you do go there, you could become a network engineer on a physical side of it. You can take over, Kamran. I have a little problem going on here with family.
Sure. Also, I was saying, actually, the basics, why do we need to learn basics? Because cloud, people think that cloud is something different than IP subnetting or something. Okay, I think Danish has some issue. No problem. So I will jump into the lab. And I will demonstrate how you can configure. So basically what I'm going to do, this lab is going to cover, first we will log in into AWS, and later on we will share how you can log in into AWS. Basically, you must have, some credit card information or Visa card information to log in into this AWS console. Otherwise, they will not let you in. So you must have that one identification to have your own account. So this is the only barrier you have to face. So if you have Visa card, credit card, something like that, it will be like a piece of cake. Then we will deploy EC2 instance. On top of that, we will deploy server 2019. And then we will access that server from my own machine locally. So any confusion until here? Or shall I move to the lab directly?
I'm good.
Okay, Christelle, if you have any.
No, I don't have.
Okay, that's fine. So this is the last, by the way, lab, and this is the last slide as well. So So can you see, this is basically the console. Can you see the page?
Yes.
Yeah. So this is the AWS console. Okay. Whatever you will do, everything will be pinned here. It will be like pinning, everything will be pinning here, whatever you will be using. So this is the landing page. The most important pieces I just can mention under here. You can see, just a minute. Here you can see your billing information. Okay, under your name. Then we have the security credentials here. And then you can take a look for your account settings and everything. Then these are the regions. I was talking about earlier, the regions. And these are somehow important. Currently I am logged into this region, Ohio. I should be in a Asia Pacific, because why? Because my location is in Pakistan. Why do I need to go all the way to US East when I can reach these my servers, which are very near to me, like Asia? Okay. So you can change the region as well here from here, but I will keep it this as it is because we are going into demo. Otherwise, if you are sitting somewhere in America, you must choose this thing. If I'm sitting in Asia, I must choose this because this server is very near to me. Then the first thing first, I need to create the EC2 instance. For that, I need to go under services. And you can see multiple services that AWS is providing. Like compute, I talked about the compute, which has to do with EC2s, Lambda. These are the things they are using. Basically to configure a container. On top of that, you will run Linux, Windows operating system, Windows servers. Okay. Then we have to do with these storage devices. We can add storage. We have databases. Okay. We have some another developer tools. Some application developers can use that. in the bottom, what I was talking about earlier, the VPCs, that comes under network and content delivery. So when we'll go into the VPC, you will see a lot in detail about the IP subnets and everything, router gateways, everything you can configure. Then we have security as well. Okay, and then this is a new thing, that Internet of Things. You can take it as an assignment to learn about what is IoT. So we can do IoT things as well on the cloud. So this is very flexible, scalable. That is the why, and that is the reason everybody is moving toward cloud. It is very cheap. Maybe if you will deploy a server of Windows, let's say server 2019, maybe for a 1 hour, you are just going to pay just few bucks for that. Or even for a 1 day, maybe $1.
I thought that with VMware's or virtualization, things can get very expensive.
Yep. You know, the reason is because we are getting dependent on these devices. And, you know, there is a term known as pay as you go. Pay as you go. It means,
okay.
yeah, it means, you know why? Because you are very right. We are installing on daily basis these devices, and we are so much dependent on AWS or IBM or these things, okay, because we do not have infrastructure on our premises. So we are so much dependent on that thing that we are adding on day-to-day basis so many things.
So I have a question. At my job, when one of our users are dead in the water, we spin up an AWS for them, or an Amazon workspace.
Okay.
My question is, so we don't get, so the company doesn't get charged until it spins up the AWS, or it gets charged, like you have them on reserve and then you deploy them?
It depends. So actually, let's move further. Then I will make it clear for you when we will be in the EC2. I will show you something. Okay.
Okay.
Your answer, your question will be answered there. That is, I think I will demonstrate. So what you can do, we can go directly into the EC2 instance. Click on that. And these are the instances. As you can see, I am on new EC2 enter experience. So these are the EC2 what I was talking about. So Hefa, I will install the service here, and then I will show you how they charge basically. Okay.
Okay.
And then you will have better idea what is going on. And so we are under instance. Okay. And we are going to create an instance for some device. Okay. So click on the, if I can show you again, click on this button, launch instances. Click on that. You will see choose an Amazon machine image. Now you will see the plethora of devices here, as you can see.
These are images that the company created, or that you're, that, like if sorry, images like.
Okay, I got your question. These are the ready-made images already provided by AWS.
Okay, but
okay.
I can add my own image?
Yes, you can add. You need to search that specific device and then you can add.
Okay.
Okay. But they will charge in case if, of course, nothing is free. And if I can show you this, it is written what? Free tier eligible. If just can zoom in.
Yeah, I see that. Okay.
Okay. So these are the things you can use if you are, just doing for the demonstration purpose. You can use these images. But if you will go further, when you will start deploying these devices, you know, there will come a part, they will basically tell you that this is the cost of this device. Okay, and I will show you just a minute. For example, if I want to deploy some Windows machine like this one, 2019 server, select this one. So once you are in the instance of this server 2019, you will see we have so many things, like how much memory it has, how many CPUs does it have, how much storage it can have. Okay, so this is free tier. That way, you know, it is limited, like 1 CPU, 1 memory of 1 GB. But as you will see here, we have multiple other instances with having like memory of 4 GB. They have 2 CPUs. And even if you will go deep further, you will see they have 16 GB RAM and then 4 core CPUs. Okay, so select this one and click on the next configure instance detail, click on that. Here, number of instances, how many copies you want to create for this server. You can make like 2, 3, 4 in a single click, like you are going to create multiple copies of the same server from here. Then there comes that part, purchasing option. If you click this one, it is gonna show you how much it is gonna charge.
Okay.
Okay, but this is like free tier. But you know, if you want to like add more resources into that, this is how they're gonna charge you for that. But we do not want, because this is just, we are going for the demo purposes. And this is by default VPC, as I mentioned earlier, the region. So keep it as it is. If you want, you can add another VPC and you can put from here like drop down. And let's say I create like New York, and I can add that my resource into that VPC. And these are the subnets, what kind of IPs I can use. So you can create, if you want, you can create multiple subnets, like range is 172 or something like that if you want. But this is like auto assign. Subnet is by default. And by the way, when I will deploy this machine, it will be assigned IP automatically from the public IP. So I will keep, for the sake of simplicity, I will keep these everything as it is. Okay, because there are not so much that I want to show you. And this is also another part, tenancy. If you want to like dedicated, it is gonna charge you more. So I will keep shared. This is a shared environment. So after that, just click on the next add storage. Now it has to do with the storage. How much storage I need to have for this device. By default, it is 30 GB. But if I will add more, it is gonna cost me. Okay, it is written that free tier eligible customers can get up to 30 Gbps only. Okay, so if you want to go increase, because your company's policy, this is what I was, this is what Hefa, you are saying that, you know, it costs more. Why? Because our needs are increasing.
I see. Okay.
Yeah. So this is because demo purpose, I can use 30 GB. But what in case when you will deploy, you know, high-end resource devices or this applications on your machine, what you're going to do, which require a lot of space and memory, of course, you need to increase. Okay.
Yes,
After
makes
that,
sense.
yep. After that, just click on next tab, add tags, and you can add a tag. This is just for the sake of information. Let's make it name server 2019 and click configure security group. Okay, here you can give a unique security group name like server sec group. This is just a unique name for the identification. In which group this system is going to be. Then these are the very important parts. RDP. This is like if I can show you remote desktop. Can you see this thing?
Yes.
Okay. So this is RDP. So this is correlate with this thing. With this RDP. And now you can see it is using TCP protocol and the port range is 3389. So it is going to use 3389 for accessing this my server from RDP. If you want, you can add more services like add rule. And then you can use like HTTP services to access this system, which is using 80. Then further, you can select like HTTPS as well, which is using 443. So basically, this is giving me idea how can I access my devices. So click on a review and launch. Here we have, this is just like the summary. And then click on the launch. So this is also very important. I previously created one JSS pair key. This is basically your password. I want to create a new one. Because every device has the password. So we can just create like server 2019 key. And you need to download this key because you need it later on. So click download and just on the desktop with the same name and save it. So it is saved here. After that, click on the launch instance button. So it is saying your instance are now launching. So to view the instance, click on this view instance button. As we can see, it is here, this server 2019, the instance that we created. And if we want, we can go a lot in detail about this instance. Like it will give me the information about, this is my public IP, which I will access this system from. This is my private IP, and I told you in regions, in availability zones, there is public and private. So these are those things. Then we have some other like security, networking related. Then we have like tags, which I mentioned earlier, the tag that I created. Monitoring, if you want to monitor the device, like the CPU, process, everything, you can take a look here as well. Okay, then storage, it will give me the information about the storage as well, like 30 GB of volume. Okay, so as we can see, it is running. So how to access this device? So just click on that one. And what you can do, you can copy this public IPv4 address from here. Or there is another way as well. You can go into this instance. If you want to go back into that instance, just click on that instance and select this one. Then there is something related to the RDP, which I can download directly, which I'm not sure where is that. Because very frequently, you know, these AWS, they change these the look and feel of those things. So let me check. Okay, no problem. What we can do, we have multiple, like you can click on this thing, and it will take me to this public IP of this host machine. It is not connected. Let me check if it is running or no. So it is still initializing, you know. Yeah, it is running, but still these two things you need to take into account. System status check, it should be okay running, and this instance status check here as well. It should be running. So let's dig deep if we can do refresh this one. So as you can see now, it is showing me the reachability check passed and these things. So let me check again how I can take that RDP.
Maybe you can use the action and connect it from there on top where it says connect.
Yep, other things I can do, I just copy this one. I need to go into RDP.
Yeah, directly.
And then paste it here and connect it. Now I need to provide the administrator, and the password is, you know, that is the thing. The password I'm looking for. Just a minute. If we can go security. This is the key pair information that I generated earlier. You can take a look of that as well. Basically, it gives me, you know, somewhere information about downloading that RDP directly.
Yeah, if you try the connect on top, see if that gives you that.
Okay, that's fine.
On top, there's a button. There you go. Just click on connect. No, go back. That connect
This?
right above that. Yeah. Right
this
above.
one?
Do you see?
Yeah, this one. Okay.
Yep.
Yes, instance summary for, okay. Connect this one. Yep. Thank you so much, Tanish. Okay. So this is like RDP client senior. From here, you can download this remote desktop. Okay. So before downloading, what we need to do, we need to get the password first of all. So click on that. And we need to browse into that file, the key pair which we generate. So server 2019, just click on that. And this is like the encryption. I need to decrypt my password to get the password. So click on decrypt. And this is the password here. So copy this one and keep. Yep, Danish.
I remember it. I just looked.
Okay, that's fine. So we need to go again into that RDP. Server manager, RDP client, and then you can download that remote desktop directly. Desktop, save it, and run it. And click on the connect. And then just need to paste the password. And click on OK. Click on yes.
So now we are on the cloud, running this server on the cloud.
Okay, so this is a server that is installed. And if you want to confirm how this is the same server, we gave, you remember the 13 GB of hard disk to this device. So you can go into this file explorer. Just to confirm that this is the same thing that we provided in the, yeah, as you can see, this is 30 GB. So this is the process of, installing EC2 instances and then accessing those servers from your RDP locally. So to disconnect, just click on this one and click OK. After that, make sure to delete that device, because maybe it is keep running some instances, and the problem could be you will be charged. Okay, so I just give you this as well. So in case if you want to delete this device, select this one and click on this instance state and click on the terminate instance, and click on that and click terminate. After some time, this device will be gone from here. Okay, so this was the demo on the AWS Cloud, and with that, your lab ends.
Think about it from a learning perspective. Imagine if you go to a work right now, you got a job, right? And this director say, hey, so by the way, our website is running under AWS or Azure. So, and that's very common. When we say a lot of people are on a hybrid setup, their normal local technologies, like let's say, for example, local server, local domain controller, things like that, they use virtualization. So you already know the power of virtualization. That's been there for years now. But so far, not many people may just move their local servers to all the way up to the cloud, because yes, it does cost them money. Even if you go pay per use, there are certain servers you have to run it 24/7. You can't just shut them down, right? So people are using both. So where does it really save you money these days? A lot of people have CMS systems, right? This is where they got their their content management systems and some of the CRM systems. These are powerful systems that every single company almost use. And every company, like I said, have some type of front-end websites. Those websites have to run from some servers, right? So if you were an engineer, and I'm going to go back to One Man IT Show again, if you were that engineer and they are using certain type of setup, then who's going to manage this stuff? You, right? So you need to know why my website is down. Now we're not talking about VMware or here. We're not talking about local servers or hardware. We're talking about you getting into a server that is running that website. So imagine if you don't know these things. How to even RDP to a machine is going to become a pretty big headache for you. Just getting into AWS, to be honest, if I'm new to this stuff, I would lose my mind in a way that, wow, to get to RDP, that's a lot of process, right? But once it's running, it's running. Everything is pretty smooth. Same setup for Azure, same thing. So at least at the basic level, try to understand or learn. In your cases, probably learn Azure first and then go into AWS, because here you're more of a Windows, coming from a Windows background. So I think that will make more sense. But I'm not trying to promote one over other, because AWS is, again, it's a pretty big cloud provider. So that's number one. After that, we have Azure. So the whole point is that even if you are going to do cloud, you still need to understand how your cloud devices has to come back and connect to your network. At this point, I think your focus has to be that. Right now, I don't want you guys to get into more cloud and try to understand cloud at the very deep level, because that is something we're going to cover in different trainings. Or we already have some labs and things for that. I don't want you to go into extreme deep of this stuff. But the main point of this whole lab was that you still need to know the basics of networking, because even if you go to the cloud, that RDP server, if it's running websites or whatever it runs, it has to come back to your network, and your firewall has to know about it. You have to enable certain things. You may even do connection between a cloud and your local network. And for that, you need to know your ASA or any firewall devices for that to work. So we're back into where you are going to get stuck again. And I can guarantee so many people actually came to me and they have actually landed cloud engineer jobs. And then they're like, Danish, I don't know the basics on an on-prem level. So I'm stuck right now because this project requires me to connect my ASA with the cloud. And this client is going to do this in 2 weeks. So now you're stuck. So the whole idea of this is to just show you how things are happening. You don't need to learn everything at once. Your focus has to be networking first. And then whatever we have shared in the Network Plus, because it's a Network Plus training, whatever we have shared is just giving you the reality of if you were to get a job, yes, you are going to touch everything then, almost everything. Unless you go for a company that is a very big company and they only want you to do switching and routing, yes, that is possible. But that would be a very unique and a very big job or someone who just hired you with that stuff. If you were to get hired right now as a network engineer, a junior network engineer, they expect you to whatever we talk today. I think 70% of the things you will be doing on all of these levels, you're going to be working on it. So with that, let's end this training for today. I hope it was beneficial and let's just end it. Do you have any other last comments?
I just want to say thank you. It was the first time to see AWS, so I am happy to have kind of basic. Thank you.
Right. All right. I think Haifa, are you here?
Yes,
so do you have any
yeah,
questions?
No questions. Thank you so much for all your time.
All right. So we'll put it up soon. And again, Kamran, as usual, thank you so much for explanations and everything. And of course, please don't give up on the test out. That is very important. Keep continuing that. Keep trying these labs and everything. And let's meet. The next session is going to be also pretty cool. So let's meet on coming Saturday. And
Sure.
with that, everybody take care. Have a great weekend.
You too. Bye,
You
everyone.
too.
Bye.
Bye. Bye.